Hello there and welcome to Biology with Charles, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we're settling in with something small, common, and surprisingly dramatic. A chemical messenger that can turn a peaceful spring afternoon into a sneezing fit, a cat cuddle into a runny-nosed regret, or a perfectly innocent peanut into a full-body alarm. That tiny troublemaker is histamine, and if the name sounds a bit stern and scientific, don't worry. Underneath it is a story that is deeply human, slightly inconvenient and oddly fascinating. It is the story of why the body sometimes reacts as if a speck of pollen were a full invading army, why the nose starts running like it has somewhere urgent to be, and why the skin can suddenly decide that itching is now its full-time occupation. Before we ease into it, I'd love to know, where are you listening from tonight, and what time is it in your little corner of the world? Maybe it's late evening, and the day has finally started to loosen its grip. Maybe it's raining where you are. Maybe the air outside is full of spring pollen doing its very best to be offensive. And if you find this soothing, helpful, or simply a gentle way to wind down, I'd be ever so grateful if you gave the video a like and maybe subscribed. It helps this calm little space reach other people who might enjoy drifting off while learning why their own immune system occasionally behaves like an overenthusiastic security guard. Now, get comfortable, let your thoughts slow down a touch, and let's begin with one of the stranger truths about the human body. Sometimes the things that make you miserable are not poisons, not infections, not injuries, but protection signals. Your body, in many allergic reactions, is not trying to harm you. It is trying, rather clumsily, to help. That is one of the first important things to understand about histamine. It is not some evil substance that appears only to ruin picnics and block sinuses. Histamine belongs to you. Your body makes it. Your immune cells store it. Your tissues use it. In the right context, it plays real and useful roles in defense, communication, and regulation. It helps blood vessels open wider when the body thinks there is a threat. It helps immune cells reach the place where they are needed. It can affect the stomach, the skin, the airways, and even parts of the brain. Histamine is not an outsider. It is one of your own internal messengers. The problem begins when the message is too loud, poorly timed, or aimed at the wrong target. It is a little like a fire alarm that absolutely has a purpose, but becomes far less charming when it starts screaming because someone made toast. Allergic reactions often feel mysterious because the trigger seems so ordinary. Dust, pollen, pet dander, shellfish, a bee sting, a certain medication. To one person, these are just parts of life. To another, they are the beginning of sneezing, swelling, itching, coughing, wheezing, watery eyes, or something much more serious. That difference can feel unfair, and in a way it is. The body of one person sees a drifting grain of pollen and shrugs. The body of another sees the same pollen and reacts as though the gates of the city have been breached. And histamine is often one of the first loud voices in that reaction. What makes this so interesting is that the body is not confused in a random way. It is following a system, a pattern, a set of biological rules that are trying to do something sensible. The system evolved to notice threats quickly and respond before those threats could do real damage. If a parasite, venom, toxin, or injury entered the body, speed mattered. Delay could be dangerous. So the immune system developed ways to react fast, to widen blood vessels, bring in defenders, increase fluid movement, and create local inflammation. Those responses can be helpful when the danger is real. But in allergies, the system often mislabels harmless things as dangerous. That harmless thing might be a peanut protein, cat saliva proteins drying on fur, mold spores in the air, or tiny bits of grass pollen floating through sunlight like nothing more than golden dust. The immune system, however, may take one look and declare a full emergency. There is something almost absurd about the mismatch. A body that can tolerate city air, late-night snacks, and questionable life choices may suddenly draw the line at strawberries or birch pollen. and yet this odd overreaction is not rare. Allergies are common across the world, and in many places they seem to be increasing. Some people spend half the year with tissues in every pocket, eyes watering as though they have just watched a very emotional film about a loyal dog. Others deal with eczema, hives, food reactions, asthma tied to allergens, or sudden swelling after exposure to something their body has decided is unacceptable. The experience varies, but the underlying theme is often the same. The body is responding to a false alarm with very real chemistry. Histamine sits right near the centre of that chemistry. When it is released in the wrong setting or in large amounts, it begins to change the body quickly. Blood vessels widen, tiny blood vessels become leakier. Fluid moves into tissues. The inside of the nose swells and produces mucus. The skin may redden or itch. The airways can narrow. The eyes water. The throat may feel strange. In a mild reaction, this is annoying. In a severe reaction, it can become dangerous. That range is worth noticing. The same basic signalling logic can produce something as simple as a sneeze and something as urgent as anaphylaxis. That is quite a lot of power for one chemical messenger. Still, the body does not release histamine for entertainment. It does so because certain cells are primed to act when they believe a threat has arrived. These cells are part of the immune system's early warning structure. They are stationed in places where the outside world regularly meets the inside one: the skin, the airways, the digestive tract. That arrangement makes sense. These are the borders. These are the doors and windows. If the body is going to detect danger quickly, it helps to place watchful cells right where unfamiliar substances first enter. The problem again is not that the guards exist. The problem is that sometimes they tackle the mail carrier. One reason allergies feel so personal is that they often arrive through the ordinary acts of living: breathing, eating, touching, walking outdoors, visiting a friend with a cat, pulling an old sweater from the back of a wardrobe and discovering too late that the dust has plans for you. Because of this, allergic reactions do not feel abstract. They feel intimate. They happen in the middle of life, not in some unusual laboratory setting. They interrupt breakfasts, holidays, school days, spring walks, sleep and work. They can be mildly comic when you're on your 14th sneeze in a row and someone asks if you're alright in the tone usually reserved for people who have just survived a natural disaster. They can also be exhausting, embarrassing, painful, or frightening. There is also the strange matter of timing. Allergic reactions can be sudden. One moment everything is fine. The next the nose is blocked, the skin is prickling, the eyes are streaming, or the throat feels tight. That speed is part of what makes histamine such an effective signal. It does not whisper its concerns in a measured memo. It arrives more like a committee member bursting through a door shouting that action must be taken immediately. If the body truly faced a harmful invader, that kind of urgency could help. But when the target is harmless, the urgency only makes the body miserable faster. And yet, despite all this inconvenience, histamine is not simply a mistake. Biology rarely works in clean categories like good and bad. What matters is context. The same inflammatory tools that cause problems in allergies are part of normal defense and healing. Redness, swelling, heat, mucus, coughing, itching, fluid movement, all of these can serve purposes. They can trap, dilute, flush, isolate or recruit help. The immune system is not designed mainly to keep us comfortable. It is designed to keep us alive. Comfort, sadly, is not always its first concern. If that sounds rude of the immune system, that is because it is, at times, a little rude. To understand allergic reactions properly, it helps to stop imagining the body as a perfectly logical machine and start seeing it as an alert system shaped by evolution. Evolution is clever, but it is not elegant in the way people sometimes hope. It does not ask what would be the most pleasant arrangement for modern life. It asks what might help an organism survive long enough to reproduce. a system that occasionally overreacts may still persist if, on balance, it protects against real dangers. In that sense, allergies may be an unfortunate side effect of a defense system built for caution. Better, from an evolutionary standpoint, to raise the alarm too often than to miss the one threat that truly mattered. That logic is cold comfort when your eyes are itching because someone opened a window in April, but it is still part of the story. The story also becomes more interesting when we remember that not everyone reacts the same way. One person's immune system may remain calm around pollen but react to peanuts. Another may react to cat dander but not dogs. Another may go through childhood with no allergies at all and then suddenly develop one later. Some people carry multiple allergies. Some have seasonal patterns. Some experience mainly skin symptoms, while others have airway problems or digestive symptoms. The differences suggest that allergic reactivity is not a single simple switch. It is more like a complicated conversation among genes, immune cells, exposures, environment, timing, and previous sensitization. The body is learning, remembering, deciding, and sometimes deciding badly. There is something quietly unsettling about that. The body remembers what it thinks is dangerous. It can become sensitized to a substance after an earlier exposure, so that a later encounter triggers a much stronger reaction. That means the first meeting may pass unnoticed, while the next brings consequences. From the body's perspective, it has learned something important. From your perspective, you may simply wonder why a food you once ate without drama has now become the lead villain in your weekly routine. This immune memory is one of the reasons allergies can feel unpredictable if you do not know the underlying mechanism. It seems as though the body changes its mind overnight, when in truth it has been preparing quietly behind the scenes. And of course, the symptoms themselves are remarkably varied for something tied to the same broad process. Histamine can help explain why the nose runs, but also why the skin reddens. It helps explain itchy welts, watery eyes, sneezing, swelling, congestion, and more. That variety makes sense once you realize that histamine acts in different tissues and through different receptors, influencing blood vessels, smooth muscle, glands, and nerve endings. The results depend on where it is released, how much is released, and what else the immune system is doing at the same time. A reaction in the skin does not look quite like a reaction in the lungs or gut, even though some of the underlying chemistry overlaps. The body has many rooms, and the same alarm sounds different depending on where it goes off. It is also worth saying gently that allergic reactions are not all in the same category of seriousness. Some are mostly nuisance conditions, though nuisance can still be miserable when it happens every day. Others can become genuine medical emergencies. That distinction matters because the body's alarm system exists on a spectrum. A small local release of histamine may produce itching or swelling in one spot. A broader, more intense reaction can affect breathing, blood pressure, and multiple organ systems. The difference between annoying and dangerous is not always obvious at first, which is one reason allergies deserve respect rather than jokes alone. Sneezing can be funny. Trouble breathing is not. At the same time, understanding the biology can remove some of the fear. The more clearly we understand what histamine is doing, the less mysterious the reaction becomes. Not less serious where seriousness is needed, but less magical, less arbitrary. There is comfort in mechanisms. There is relief in knowing that the itching is not random, the swelling is not a curse, the runny nose is not your face giving up in despair. These things happen because signals were sent, receptors were activated, blood vessels changed behavior, tissues responded, and the immune system followed a program it believed was useful. The program may be mistaken, but it is still a program. Biology, even when inconvenient, has reasons. This is part of what makes the topic so satisfying to explore. Allergies seem simple on the surface. Something bothers you, you react, you reach for tissues or medicine, and you carry on. But underneath that ordinary experience is a much richer story, involving immune recognition, cell signaling, inflammation, memory, barrier tissues, genetics, and adaptation. Histamine is only one piece, though an important one, and learning about it opens the door to the wider logic of allergic disease. It invites us to ask not only what histamine does, but why the body keeps it ready, which cells release it, how the alarm gets triggered, why some people are more prone to these responses, and what we can do to calm the system when it becomes too eager. Perhaps the nicest thing about learning the biology is that it changes the feeling of the symptoms. Not completely, of course. Knowing why you are sneezing does not stop the sneezing in the moment. Science is helpful, but it has yet to discover a theory so elegant that it can clear a blocked nose by sheer explanation. Still, understanding turns confusion into structure. Instead of thinking the body is being dramatic for no reason, you begin to see the logic underneath the drama. Histamine is not chaos, it is communication. An exaggerated communication, sometimes misdirected, but communication all the same. And communication, in the body, is never isolated. A single signal leads to another. One cell activates, then another responds. Fluid shifts. Muscles tighten or relax. Nerves report itching. Glands produce mucus. Blood vessels open. Immune cells arrive. What feels from the outside like one irritating symptom is often the visible surface of a wider coordinated response. In that sense, even a humble allergic sneeze is not humble at all. It is the outward sign of a well-organized biological misunderstanding. So tonight, as we begin this gentle walk through histamine and allergic reactions, it helps to hold on to a simple picture. Your body is full of watchful systems. It is constantly deciding what belongs, what does not, what is dangerous, what is safe, and how strongly to respond. Most of the time it does this quietly and well. Occasionally it becomes overprotective. It mistakes pollen for peril, peanuts for catastrophe, cat dander for a serious insult to national security. And when that happens, histamine becomes one of its fastest tools, released into tissues as part of a response meant to protect, but often felt as discomfort, disruption, and sometimes danger. That is where our story begins, with a molecule that belongs to you, a defense system that means well, and a body whose version of caution can, from time to time, be just a little too enthusiastic. From there, the next step is to look more closely at histamine itself, not just as the name printed on allergy medicine boxes, but as a real biological substance with specific jobs, specific origins, and a surprisingly interesting life inside the body. Because once we understand what histamine actually is, and why the body keeps it ready in the first place, the rest of the reaction starts to make a great deal more sense. Histamine sounds like the sort of thing people only remember when spring arrives and their nose begins behaving like a faucet with emotional problems. It tends to enter ordinary conversation attached to tissues, antihistamine tablets, puffy eyes, mysterious rashes, or someone saying in a tone of weary experience that they really should not have gone near that cat. But histamine in truth is much older, more useful, and far more interesting than its reputation suggests. It is not just the villain of seasonal misery, it is one of the body's own messengers, a small chemical signal made from an amino acid called histidine, stored in certain cells, released at important moments, and involved in several normal functions that have nothing to do with sneezing at all. The fact that it can also turn a peaceful afternoon into an itchy disaster is only part of its story. One of the easiest mistakes to make with biology is to imagine that the body produces chemicals only when something has gone wrong. In reality, the body is constantly making, breaking down, storing and releasing substances that serve many purposes depending on where they are, when they appear, and how much of them is around. Histamine is a perfect example of that. In one setting, it helps coordinate immune defense. In another, it helps the stomach prepare acid for digestion. Elsewhere, it acts in the brain as a signaling molecule involved in wakefulness and alertness. The same molecule can be helpful, ordinary, irritating, or dangerous depending on context. Biology is rarely tidy enough to give a substance only one job. It prefers reusing good tools in multiple rooms of the same house. To understand histamine properly, it helps to picture the body as a place full of messages in motion. Cells are not sitting quietly in isolation, each minding its own business like polite strangers on a train. They are constantly exchanging information. Some signals are electrical, moving rapidly through nerves. Some are hormonal, travelling through blood over longer distances. Others are local chemical messages, released in a tissue to tell nearby cells that something important is happening. Histamine belongs strongly to that local urgent category. It is a messenger for moments when the body wants quick changes in an area, especially at the places where the outside world meets the inside one. The skin, the nose, the lungs, the gut. These are not sealed fortresses. They are living borders, and histamine is part of the language spoken there. What makes histamine especially useful is that it can create fast, visible effects. It can cause blood vessels in a local area to widen. It can make the tiny vessels called capillaries more permeable, which means fluid and immune components can move more easily out into tissues. It can stimulate glands to produce more secretions. It can influence smooth muscle, including the kind found in airways. It can irritate nerve endings in ways that create itching. These are not subtle background adjustments. They are practical, immediate changes designed to alter a tissue quickly. If the body suspects that something harmful has entered through the skin or the lining of the nose, speed has value. Better to flush, swell, recruit help, and change the local conditions at once than to wait around drafting a polite committee report. Seen from that perspective, histamine makes a great deal of sense. Imagine a threat entering through the nose or landing on the skin. The body would benefit from opening blood flow to the area, bringing immune cells closer, increasing fluid movement, and encouraging the offending material to be trapped, diluted, or expelled. Swelling, redness, mucus, sneezing, itching, watery eyes, all of these may be deeply annoying when triggered by harmless pollen, but they are not random. They are forms of action. They are the body saying that something has been noticed and that local conditions are being changed immediately. Histamine does not arrive to make you dramatic. It arrives because the body thinks the situation deserves a rapid response. This brings us to an important point. Histamine is not mainly an allergy chemical. It is a normal biological compound that allergic reactions happen to use very effectively. That distinction matters because it keeps us from imagining allergies as a completely separate, strange branch of human biology. Allergies are exaggerated uses of ordinary immune tools. The underlying substances, including histamine, belong to the normal operating kit of the body. What changes in allergy is not the existence of histamine, but the reason for its release and the scale of the response. In other words, the body is using a real defense signal in the wrong context. The body makes histamine from histidine, an amino acid that comes through diet and protein metabolism. An enzyme removes part of the histidine molecule and converts it into histamine. That process happens in several types of cells, but the most famous ones in the allergy story are mast cells and basophils, both of which are immune cells equipped to store histamine in granules. These granules are like tiny chemical packets kept ready for rapid deployment. When the right trigger arrives, the cell can release a burst of contents into the surrounding tissue. Histamine is among the most important of those contents, but it is not the only one. That is another reason allergic reactions can be so complex. Histamine gets much of the attention, and fairly so, but it often works alongside many other inflammatory mediators. There is something almost theatrical about the way histamine is stored and released. It does not drift around lazily waiting to be useful. Much of it is kept packaged, ready for a moment of activation. That arrangement is clever. If the body had to synthesize every bit of histamine from scratch during an acute reaction, the response would be slower. By storing it ahead of time, the body can react almost immediately when those storage cells are triggered. In evolutionary terms, that is valuable. Parasites, venoms, injury, and invading organisms do not usually announce themselves politely several days in advance. A system that can answer fast has a survival advantage, even if in modern life it sometimes misfires at the sight of a peanut. Histamine also acts through specific receptors, which are proteins on or in cells that recognize it and respond. 4 main histamine receptors are known in humans, called H1, H2, H3, and H4. Their names sound like the seating plan of a moderately unfriendly conference room, but each receptor has its own tissue distribution and effects. H1 receptors are strongly involved in the classic symptoms people associate with allergies, including itching, sneezing, runny nose, swelling, and some airway effects. H2 receptors are important in the stomach, where histamine helps stimulate acid secretion. H3 receptors are mostly associated with the nervous system and help regulate the release of neurotransmitters. H4 receptors are involved in immune cell behavior and inflammation. That receptor diversity is one reason histamine can participate in such different aspects of physiology. The molecule itself is the same, but what happens depends on which receptor it binds to and where that receptor happens to be. This is why antihistamines are a little more specific than people sometimes realize. When someone takes a typical allergy antihistamine, the medicine is usually blocking H1 receptors, aiming mainly at the pathways involved in allergic symptoms. It is not erasing histamine from the universe. It is interfering with one major route through which histamine exerts particular effects. Other drugs target H2 receptors to reduce stomach acid. That too is histamine biology, just a different room in the same house. Histamine is less like a single-purpose burglar and more like a staff member with access badges to several departments, some helpful, some troublesome, all very busy. The stomach side of histamine is a good reminder that the body makes this molecule for practical reasons beyond immunity. Specialized cells in the stomach release histamine as part of the process that stimulates acid production. That acid helps digest food, especially proteins, and helps control microbes that enter with meals. So even before pollen season ruins anyone's mood, histamine has already been quietly involved in an ordinary lunch. It is a useful little lesson in biological humility. The same molecule blamed for itchy eyes, after a walk in the park, may also have helped you process your dinner. Biology does not organize itself around our convenience. Then there is the brain. Histamine acts there as a neurotransmitter and is involved in wakefulness, attention, and arousal. Certain histamine-producing neurons help maintain alertness. This is one reason some older antihistamine drugs make people sleepy. They cross into the brain and block histamine's action there, dampening some of the signaling that supports wakefulness. Hence the curious human tradition of taking one sort of tablet to stop sneezing and accidentally discovering that consciousness itself has become optional. Newer antihistamines are often designed to avoid crossing into the brain as much, which helps reduce drowsiness. Still, that sleepy side effect serves as a useful clue. Histamine is not merely about allergy. It is part of how the body helps regulate whether you feel awake. All of this makes histamine sound impressively versatile, which it is, but it also raises a sensible concern. If histamine is involved in so many normal functions, why does the body allow so much of it to be released in ways that cause misery during allergies? The answer is that the body did not design histamine for allergies. It designed, if that word may be used loosely, a rapid response system for defense and regulation. The downside comes when immune recognition makes a mistake. A harmless substance enters, immune cells that have been primed to regard it as threatening become activated, and histamine is released as though a genuine danger were present. The molecule is doing what it always does. The error lies upstream, in what the body has decided histamine should be released for. That upstream mistake matters enormously. Histamine is not an independent decision-maker wandering through the body, causing trouble as a hobby. It is a downstream messenger. It reflects a prior judgment made by the immune system. If the immune system has been sensitized to pollen, for instance, and pollen enters the nose or eyes, the release of histamine follows as part of a broader response. It is a consequence of immune recognition, not the original cause of the allergy itself. This helps explain why blocking histamine can reduce symptoms without necessarily curing the underlying allergic tendency. You're softening one major signal in the reaction, not rewriting the immune system's memory. There is another detail worth noticing. Histamine's effects are often short-range and local, which makes sense for a chemical meant to act quickly at a site of potential trouble. A grain of pollen landing in the nose does not usually require the entire body to respond equally. The most useful response from the body's perspective is local. Swell the lining, produce mucus, recruit cells, irritate nerves into sneezing, and change blood flow right there. Histamine is good at that kind of neighbourhood action. Its power lies not in being mysterious, but in being practical. It changes tissues in ways that can happen fast and be felt immediately. Those immediate changes explain many classic allergy symptoms. The runny nose comes partly from increased glandular secretion and fluid leakage from more permeable blood vessels. Congestion comes from swelling in the tissues of the nasal lining as vessels widen and leak. Itching comes from stimulation of sensory nerves. Redness comes from increased blood flow to an area. A raised hive on the skin reflects local vessel changes and fluid movement. Watery eyes follow similar logic in delicate tissues that are rich in nerves and vessels and exposed to the outside world. Histamine is not doing one grand thing called allergy. It is producing several tissue-level effects that, together, feel like an allergic reaction. That local logic also reveals why histamine can be so uncomfortable without always being harmful in a lasting sense. Its symptoms are designed, in principle, to create action. Scratch this, flush that, move fluid here, constrict there, bring cells in, make the organism notice. Unfortunately, noticing often feels terrible. Itching, for example, is not a meaningless annoyance. It is a sensory signal designed to make you pay attention to a part of the body. Sneezing is not merely comic. It is a forceful expulsion mechanism. Mucus is not elegant, but it traps and carries things. Swelling is not pleasant, yet it changes local blood flow and immune access. Histamine sits behind many of these ancient bodily tactics, and ancient tactics are often effective in ways that are not especially refined. Because histamine is so strongly associated with allergies, it is easy to forget that some people can also have problems when histamine handling in the body is altered in other ways. Certain foods contain histamine or can promote its release. The body also has enzymes that help break histamine down, especially in the gut and tissues. If histamine production, intake, release or breakdown shifts unusually, symptoms can sometimes overlap with allergic ones, even when the mechanism is not exactly the same as a classic IgE-mediated allergy. This area is more complicated and sometimes discussed loosely online, often with more certainty than the science deserves, but the central lesson still holds. Histamine itself is a real physiological player, and its effects are broader than one neat textbook picture. The reason the body keeps histamine ready, then, is not difficult to understand once we stop judging it by the standards of a comfortable weekend. The body keeps histamine because rapid local signaling is useful. It helps defend border tissues. It helps coordinate inflammation. It helps support certain digestive functions. It helps regulate wakefulness in the brain. It is quick, potent, and adaptable. A body without histamine would not be a cleaner, calmer, superior model of itself. It would be missing an important part of its communication network. The trouble begins when that network is activated against the wrong things or too strongly. There is a certain irony in the whole arrangement. The same body that can calmly tolerate countless harmless environmental particles day after day may suddenly react to one familiar substance as though it were a major offence. And the chemical that carries out much of that response is not exotic at all. It is a built-in molecule the body normally trusts. Histamine is a loyal messenger, perhaps a bit intense, but loyal. If it causes chaos, it is usually because it has been given instructions that made sense only from the immune system's mistaken point of view. That is why understanding histamine can feel oddly reassuring. It takes allergic reactions out of the realm of personal betrayal and places them back into biology. Your body is not being silly in a meaningless way. It is using a legitimate signalling system with inappropriate confidence. Histamine is part of that system because, under many circumstances, it works. It is fast. It changes tissues effectively. It helps coordinate early defense. It can support digestion and alertness. It is a useful molecule placed in the service of an immune system that, in allergies, has become too suspicious of harmless things. Once you see that, the next part of the story naturally comes into focus. Histamine may be the signal, but signals do not release themselves. Someone has to store them, guard them, and decide when the moment has come to let them loose. That leads us directly to the cells that act as the body's loaded alarm points, especially the mast cells waiting in tissues and the basophils circulating in the blood, because understanding those watchful immune cells is where histamine stops being just a molecule on a label and becomes part of a living, reactive system ready to spring into action. If histamine is one of the body's fastest warning signals, then the next thing to understand is who keeps a finger near the alarm. Chemicals do not leap into action on their own. They are stored, guarded, and released by cells that have been positioned very carefully in the places where the world tends to press closest against us. And among the most important of those cells are mast cells and basophils, two members of the immune system that are easy to overlook until they decide that today, of all days, a tiny bit of pollen deserves a full public response. They are not identical twins, and they do not live in exactly the same places, but they share an important talent. They are packed with potent chemical mediators, including histamine, and they are built to react quickly when they believe a threat has arrived. In the story of allergic reactions, they are some of the earliest and loudest responders, the watchers at the gate who are meant to protect the border, but sometimes tackle entirely innocent guests with remarkable enthusiasm. It helps, at this point, to imagine the immune system not as one single army marching in neat formation, but as a layered security network spread across the whole body. Some cells are patrolling, some are analysing, some are remembering past encounters, some are stationed permanently in places where breaches are likely to happen. The skin, the lining of the nose, the airways, the digestive tract, these are not just tissues that happen to exist. They are frontiers. Every breath, every meal, every touch of the outside world brings material into contact with them. Most of it is harmless. Some of it is useful. A little of it may be dangerous. So the body places sentinels there, cells that can recognize trouble and act before a local problem becomes a bigger one. Mast cells are among the most important of these sentinel cells. Mast cells live in tissues rather than mainly circulating through the blood. They are especially common near surfaces that interact with the outside environment and near blood vessels and nerves. That is not an accident. It is a practical arrangement. If a threat enters through the skin or the lining of the nose or gut, mast cells are already in position. They do not need to be summoned from far away before acting. They are on site, stocked, alert, and capable of changing local conditions within moments. In many ways, they are like security staff permanently stationed by doors and windows, except that instead of radios and stern expressions, they carry granules full of histamine and other inflammatory substances. Those granules are central to what makes mast cells so effective and, in the case of allergies, so troublesome. Inside them are preformed mediators, substances the cell has already made and stored in readiness. Histamine is one of the major ones, but mast cells also contain things like proteases, enzymes that can help shape tissue responses and inflammation. When the cell is triggered, those granules can be released in a process called degranulation. The name is wonderfully plain for something that can feel so dramatic. Degranulation means the cell is emptying out a store of pre-packed chemical signals into the local environment. That is one reason allergic symptoms can begin so quickly. The body is not improvising everything from scratch. It already has loaded containers sitting inside these cells, waiting for the instruction to open. Basophils are closely related in function. though they are much rarer in the blood than many other white cells and tend to circulate rather than settling long-term in tissues the way mast cells do. They also contain granules rich in histamine and can participate in allergic inflammation. If mast cells are the residents posted along the body's borders, basophils are more like mobile responders travelling through the bloodstream, able to join reactions and amplify them when needed. They are less numerous, but they matter. In allergy and certain parasite responses, they contribute to the same broad style of immune activity. Both cell types are especially famous for their relationship with a particular class of antibody called immunoglobulin E, or IgE, which plays a starring role in many immediate allergic reactions. This is where the immune system becomes a little more personal and a little more suspicious. Antibodies are proteins made by B cells, and they are part of the adaptive immune system, the branch that learns from exposure and remembers what it has encountered. Different classes of antibodies do different jobs. IgE is particularly important in responses to parasites and in allergies. Mast cells and basophils carry high affinity receptors for IgE on their surfaces. That means IgE can bind tightly to them and remain there, almost like little identifying tags held ready on the outside of the cell. If a person becomes sensitized to an allergen, such as a pollen protein or a peanut protein, the immune system can produce IgE specific to that substance. That IgE then binds to receptors on mast cells and basophils, effectively arming those cells for future encounters. This part is worth lingering over, because it explains why allergic reactions often involve prior exposure. The first encounter with an allergen may not cause a dramatic reaction at all. Instead, it may be the event during which the immune system decides wrongly that this harmless substance is worth remembering as dangerous. B cells are induced to produce allergen-specific IgE. That IgE binds to mast cells and basophils. The cells are now sensitized. They are loaded with the right recognition system, and the next time that allergen appears, it may cross-link the IgE molecules on the cell surface and trigger degranulation. In other words, the body has quietly set the trap in advance, and the second visit is when the alarm truly sounds. That mechanism is both elegant and unfortunate. Elegant because it allows for very fast responses to substances the immune system has already decided are important. Unfortunate because in allergies the decision itself is a mistake. The substance may be harmless, but the immune system has stored a memory of it as though it were a meaningful threat. Mast cells and basophils do not know the broader philosophical argument. They are not standing there debating whether birch pollen has really earned this level of concern. They are responding to a molecular pattern presented to them through IgE, and once enough receptors are cross-linked, they act. When mast cells act, they act quickly. Histamine is released almost immediately and nearby tissues begin to change. Blood vessels widen. Fluid leaks more easily from tiny vessels into surrounding tissues. Glands are stimulated. Nerve endings begin signaling itch or irritation. Smooth muscle can contract in certain tissues, including the airways. That is the early phase, the rapid part people recognize as the sudden onset of allergy symptoms. But mast cells do more than simply dump histamine and retire for the day. They also begin producing and releasing newly synthesized mediators, including leukotrienes, prostaglandins, and cytokines, which help recruit other immune cells and sustain inflammation over a longer period. So the mast cell is not just a tripwire, it is also a coordinator, helping shape the reaction that follows. This is one of the reasons allergic inflammation can outlast the first burst of symptoms. Histamine may explain a great deal of the immediate sneezing, itching, redness, and swelling, but the broader inflammatory process involves many other signals and many other cells arriving later. Eosinophils, T cells, and additional inflammatory mediators may all join the response depending on the type of allergy and the tissue involved. The mast cell, then, is not simply a chemical sac that bursts. It is a highly active immune cell that can direct traffic, change the environment, and influence how long the reaction lasts. That makes it both biologically impressive and, from the point of view of springtime sinuses, a little exhausting. Its location near nerves is especially interesting. Mast cells often sit close to nerve endings, and the substances they release can influence nerve activity. That is one reason itching can feel so immediate and so insistent. The mast cell is positioned not only to change blood flow and tissue permeability, but also to help make sure the organism notices. The body is not trying to provide a refined sensory experience. It is trying to make you aware that something is happening right here, right now. Scratch, sneeze, cough, move away, pay attention. These are not elegant messages, but they are effective. A quietly philosophical itch would not have gotten our ancestors very far. Their location near blood vessels matters just as much. By sitting near the vascular supply, mast cells can quickly affect how much blood arrives, how leaky the vessels become, and how easily immune cells can exit the bloodstream into tissues. That is ideal for early defense. If a parasite breaches a barrier or a venom enters the skin, rapid vessel changes can help mobilize a response. In that context, the mast cell's dramatic style makes sense. It is not overreacting from some cosmic point of view. It is applying a fast local emergency protocol in a situation where speed could matter. Allergies take that same useful protocol and activate it for things that never deserved the emergency setting. Basophils, meanwhile, help reinforce similar patterns from within the circulation. Though far less abundant than neutrophils or some other white cells, basophils share enough features with mast cells that they are often discussed together in allergy. They express IgE receptors, contain histamine-rich granules, and can release cytokines that support type 2 immune responses, the general immune pattern associated with parasites, allergic inflammation, and certain tissue defense strategies. They may not dominate every allergic scene in the same way mast cells do at the tissue border, but they participate in the same cast of characters. In some settings, they help drive the development or persistence of allergic tendencies by shaping how the immune system interprets certain exposures. This brings us to a broader point about immune personality. Mast cells and basophils are not random accidents tucked away in a dusty corner of physiology. They are part of a whole response style often associated with worms and other parasites, especially those too large to be swallowed up neatly by a single immune cell. The body evolved ways of dealing with such threats by increasing mucus, contraction, vascular changes, and particular inflammatory cell patterns. That style of response may help expel or contain parasites, or reinforce barrier tissues where invasion is likely. Allergies seem to hijack some of that same machinery. The system built to fight one class of threat ends up reacting to harmless proteins in food, pollen, dust mites, or animal dander. It is a bit like discovering that the moat and drawbridge were excellent inventions, but someone has now decided to raise them every time a neighbour drops by with biscuits. Mast cells are also fascinating because they are not all exactly the same. Different tissues can host mast cells with somewhat different characteristics, depending on local signals and developmental influences. A mast cell in the skin is not necessarily identical in behaviour to one in the gut or lungs. This variation helps explain why allergic disease can look so different depending on where it occurs. The core players may be familiar, but the tissue context matters. In the skin, local mast cell activation may produce hives, redness, swelling, and itching. In the nose, it leads to congestion, sneezing, and watery discharge. In the lungs, it can contribute to bronchoconstriction and asthma symptoms. In the gut, it may help drive cramps, swelling, altered motility, or other distress. Same general alarm system, different building, different consequences. This tissue-specific reality is why allergic reactions are best understood not as one single event, but as a conversation between immune cells and their surroundings. The mast cell listens to one set of signals from IgE and allergen binding, but it also responds to the local tissue environment, to cytokines, to nerve signals, to complement components, and sometimes even to physical or chemical irritation. Mast cells can be activated in more than one way. Allergies often centre on IgE-mediated activation, but mast cells are broad responders capable of reacting to many forms of disturbance. That versatility is useful in immunity and inconvenient in modern life, especially if one's modern life includes surprise insect stings, seafood restaurants, or an ambitious attempt to clean a dusty attic. It is worth pausing over how little these cells care about appearances. To you, a cat may be a pleasant companion with nice ears and deeply questionable respect for boundaries. To a sensitized immune system, cat proteins may be an identified concern. To a mast cell coated in the relevant IgE, that concern is molecular and immediate. It is not evaluating whether the cat is charming, it is matching patterns. That pattern-based nature of immunity is both its strength and its weakness. It allows fast recognition without requiring contemplation, but it also means that harmless substances can be condemned once the system has learned the wrong lesson. Mast cells and basophils are not wise judges, they are rapid enforcers, and rapid enforcers need restraint, which the immune system usually provides through many layers of regulation. Healthy immunity is not simply aggression. It depends on tolerance, context, and controlled thresholds for action. Barrier tissues, regulatory T cells, cytokine balances, microbial exposures, and genetic influences all help shape whether the immune system learns calmness or alarm toward a given substance. When allergic disease develops, something in that broader educational system has shifted. The body is not just armed, it has been taught suspicion. Mast cells and basophils are the cells that carry out the response, but they are acting within a larger immune culture that has become too ready to see danger in the harmless. That larger culture also explains why allergic responses can become self-reinforcing. Once mast cells are activated and inflammation begins, the local tissue may become more reactive, nerves more sensitive, and the barrier more disturbed. Repeated exposure can keep the cycle going. The nose becomes the sort of place where very little is needed to cause trouble. The skin becomes irritable, the lungs become twitchy. Over time, the boundary between reasonable caution and absurd overreaction grows thinner. The immune system is, in effect, practicing the wrong drill until it becomes very good at it. Still, it would be unfair to talk about mast cells and basophils as though they were nothing but troublemakers. Outside of allergy, they play real roles in wound responses, defense against certain infections and parasites, tissue repair signaling, and maintenance of barrier function. A mast cell is not inherently a bad idea any more than a smoke detector is a bad idea. The issue is calibration. When calibrated well, the system notices meaningful disturbances and helps protect the organism. When calibrated poorly, toast becomes a 5-alarm fire. That is not a failure of the concept of alarm. It is a failure of what the system has come to classify as dangerous. There is something almost tragicomic about this from the human point of view. The body has stationed attentive, chemically armed guardians at the exact places where life is lived most normally. In the nose that greets spring air, in the skin that meets sunlight and wool sleeves, in the gut that welcomes dinner, in the lungs that trust the next breath. These guardians are there because those are the gates, and gates need watching. But once the immune system has mislabeled something harmless, the guardians become overzealous. The gate remains real. The vigilance remains real. Only the threat is imaginary. And that imaginary threat is the next crucial part of the story. Because once we understand who the watchers are and how they stand ready, the obvious question becomes how they learn to distrust the wrong things in the first place. Why harmless pollen, peanuts, dust mites, or pet dander are treated as though they were genuine invaders, and how the immune system comes to make that particular mistake with such confidence. One of the strangest things about allergies is that the body is not reacting to something truly dangerous in the ordinary sense. Pollen is not trying to conquer you. Dust mites are not plotting anything ambitious. A peanut, for all its confidence in trail mix, is not a hostile organism mounting a tactical operation against your throat. And yet the body can respond to these harmless things with a level of alarm that would be much more understandable if the threat were a parasite, a venom, or a serious infection. That mismatch is the heart of allergy. The chemistry may be real, the swelling may be real, the itching may be very real indeed, but but the threat itself is often not what the body thinks it is. So the next question becomes obvious. How does the immune system make that mistake? Why does a harmless substance end up wearing the molecular equivalent of a fake villain's moustache? To answer that, it helps to remember what the immune system is actually trying to do. Its job is not to understand the world in a philosophical way. It does not sit calmly in contemplation deciding whether a substance has good intentions. It works through recognition patterns, past experiences, thresholds for alarm, and a large number of signals exchanged between cells. It is less like a wise old judge and more like an enormous security system built in layers over millions of years. That system has many strengths. It can learn, it can remember. It can distinguish many forms of danger from many forms of self. It can react quickly. But it is not perfect, and perfection was never the standard evolution was aiming for. Evolution tends to reward systems that are useful often enough, not systems that are elegant in every modern situation. That last point matters more than it might seem. If the immune system occasionally overreacts to something harmless, that is unfortunate for comfort, but it may still be acceptable from an evolutionary perspective if the same general response style helps protect against something genuinely dangerous. A smoke alarm that goes off because of toast is annoying, but a smoke alarm that never goes off during a real fire is much worse. Biology often prefers false positives over missed catastrophes. In allergies, the body appears to have accepted too many false positives. It sees danger where there is none because the cost of caution was, in older environments, sometimes lower than the cost of missing a real threat. The immune system also does not encounter the world as one smooth stream of obvious labels. It meets proteins, particles, fragments, chemicals, and surfaces. It must interpret them through context. Where did this substance arrive? Was the barrier tissue damaged? Were there signs of infection nearby? What cytokines were present? Which cells noticed it first? Was it encountered early in life or later? Did the body meet it through the skin, the gut, or the airways? These details all matter because immune responses are not determined by the substance alone. They are shaped by the environment in which the substance is first introduced and by the state of the tissues and immune system at that time. This is one reason the same substance can be tolerated in one setting and treated as threatening in another. The immune system is capable of tolerance, which is one of its most important achievements. Tolerance means the body learns not to overreact to harmless things, including food proteins, helpful microbes, and many environmental exposures. Without tolerance, life would be biologically exhausting in ways too absurd to contemplate for long. A meal would feel like a diplomatic crisis. A walk through a garden would resemble a siege. The fact that most people can eat, breathe, and touch the world without constant disaster is proof that tolerance is working most of the time. Allergy happens when that education in tolerance fails, weakens, or is bypassed. A great deal of that education begins at barrier surfaces, especially the gut, skin, and airways. These tissues are not passive wrapping, they're active immune environments. They contain specialized cells that sample what enters, communicate with the immune system, and help determine whether a response should be calm or aggressive. The gut in particular is a remarkable site of immune training because it is constantly exposed to food proteins and large communities of microbes. Under healthy conditions, the immune system learns that most food is not an enemy, and that many microbes are helpful partners rather than threats. The skin and respiratory tract do similar work in their own ways, helping the body interpret contact with the outside world. When that barrier education goes wrong, the consequences can echo for years. A disrupted skin barrier, for example, may allow environmental proteins to enter in ways that favour sensitization rather than tolerance. This is part of why eczema and food allergy can be linked in some children. If the skin is inflamed and leaky, proteins from the environment may be introduced to the immune system in a context that says danger rather than peace. The immune system may then produce IgE against those proteins, preparing the ground for later allergic reactions. The same protein that might have been tolerated if first encountered safely through the gut can become the target of an allergy if introduced through damaged skin. Context, again, changes everything. The gut offers another important lesson. For a long time, food allergy seemed baffling, partly because eating should be one of the clearest examples of normal exposure. Yet food allergy exists, and in some cases it is severe. Part of the explanation lies in the complex work required to maintain oral tolerance. Food proteins must be processed in a setting where the immune system is being actively encouraged not to panic. Regulatory immune cells help with this, so do the physical barrier of the intestinal lining, the presence of beneficial microbes, and the chemical environment created by digestion and local signaling. If those systems are altered, tolerance may be less likely to form properly. A body that should learn calmness may instead learn suspicion. Microbes play an especially interesting role here. The immune system does not develop in isolation. It grows up in conversation with the microbial world. Trillions of organisms live in and on the human body, especially in the gut, and these microbes help shape how immune cells mature and respond. They influence inflammation, tolerance, barrier health, and the balance between regulatory and reactive immune pathways. When microbial communities are disrupted, the immune system's education may also shift. This idea is one reason scientists have long been interested in why allergic diseases appear more common in highly industrialized environments. The explanation is not simple, and modern life is too varied to blame neatly on one factor, but reduced microbial diversity, altered early life exposures, diet, antibiotic use, urban living, pollution, and changed patterns of infection have all been considered part of the puzzle. This does not mean dirt is magic, or that every immune problem can be solved by rolling around in a field, though one suspects some children would be delighted by the prescription. It means the immune system expects a certain kind of upbringing. It evolved in close contact with a rich and varied environment. When the developmental signals it receives are different, its calibration may change. A system that does not learn tolerance robustly may become more inclined toward allergic responses. In that sense, some allergies may reflect not only the presence of a trigger, but also the immune system's history of training. Genes also matter, though genes are rarely the whole story. Some people are simply more prone to allergic disease. They may inherit tendencies toward a stronger type 2 immune responses, altered barrier function, eczema, asthma, or increased IgE production. If allergies run in a family, that is often because relatives share both genes and environments. A child may inherit a skin barrier that is more fragile, an immune system more inclined toward allergic sensitization, or both. But genes do not dictate every outcome with rigid certainty. They create tendencies and probabilities, environment, timing, exposures, infections, microbiota, diet, and sheer biological chance all interact with that inherited background. The result is a risk landscape rather than a simple destiny. The type of immune response involved in allergies is often called a type 2 response. This style of immunity is associated with IgE, mast cells, eosinophils, and certain cytokines such as interleukin-4, interleukin-5, and interleukin-13. It is useful in defense against parasites and in tissue repair at barrier surfaces, but it can also drive allergic disease. When a harmless substance is interpreted in a way that steers the immune system toward this type 2 pathway, B cells may switch to producing IgE against that allergen. Once that happens, mast cells and basophils can be armed for future encounters. The harmless substance has now been filed under danger, and the filing system is annoyingly confident. How does the immune system make that filing error? Often through antigen presentation and helper T-cell decisions that unfold in an inflammatory context. Dendritic cells and other antigen-presenting cells pick up bits of material from the environment and show them to T-cells, but they do not do so in a vacuum. They also provide information about the surrounding context. If tissues are inflamed, damaged, irritated, or rich in certain cytokines, the response may tilt toward allergy rather than tolerance. Some allergens themselves may also have properties that make them especially likely to trigger barrier disruption or immune activation. Certain pollen proteins, dust mite components, or food proteins can interact with tissues in ways that promote the wrong kind of attention. A harmless substance does not need malicious intent to be immunologically inconvenient. Timing matters too. Early life is an especially important period for immune education. The immune system of an infant is learning rapidly which kinds of exposures are normal and which are not. This is one reason modern advice about introducing allergenic foods has changed over time. For some foods, earlier introduction in appropriate settings may help promote tolerance rather than increase risk. The older idea that strict avoidance would prevent allergy turned out not always to help, and in some cases may have made things worse. Biology, once again, prefers exposure with the right education over silence followed by panic. There is also the question of dose and route. Small repetitive exposures through the skin may not teach the same lesson as regular exposures through the gut. Inhaled particles behave differently from swallowed proteins. A protein altered by cooking may be perceived differently than one in raw form. The immune system is constantly gathering meaning not just from what arrives, but from how it arrives. It is less interested in abstract categories than in practical signals. This thing entered through inflamed skin. This other thing came with food into a calm gut. One context suggests threat, another suggests normal life. Allergies often arise when these lessons are flipped the wrong way round. Once sensitization has occurred, the body becomes much more reactive on later exposure. This is the part people often experience as sudden or unfair. The first time there may have been no obvious problem. The second or 10th time, symptoms appear quickly. But the immune system has not changed its mind in a moment. It has been preparing. IgE has been produced. Mast cells have been coated with that IgE memory has been formed. The harmless substance now returns to a body already primed to overinterpret it. In that sense, allergy is not spontaneous confusion. It is educated confusion, which may be the most inconvenient kind. There is another subtle point here. The immune system is not only trying to identify harmful outsiders, it is also trying to maintain the integrity of barrier tissues. Sometimes allergic-style responses may be linked to the body's attempt to protect damaged or stressed surfaces. Mucus production, coughing, sneezing, and fluid movement can all be understood as ways of clearing or reinforcing boundaries. When the nose runs during hay fever, the body is not merely sulking, it is trying to wash and expel what it believes should not remain there. When airways narrow, that can be dangerous, but the underlying logic comes from a system trying to defend a vulnerable surface. The result may be maladaptive in modern allergy, but its roots are still protective. This is why the phrase overreaction, though useful, can be a little misleading. Allergy is not simply more reaction than normal. It is a particular kind of reaction directed at the wrong target, and often amplified by memory, barrier dysfunction, and inflammatory context. It is not just volume, it is misclassification. The body has mistaken identity at the molecular level. It has put an innocent substance on a watch list and then handed that watch list to very excitable cells. The list of common allergens begins to make more sense from this angle. Pollens are tiny proteins arriving at sensitive barrier surfaces in the nose and eyes. Dust mites live in close contact with human environments and produce materials that can become airborne. Animal dander and saliva proteins cling to hair, fabrics, and indoor air. Foods present proteins to the gut, a site where tolerance must be learned carefully. Venoms are actually dangerous in some contexts, which may partly explain why that system can be so forceful. None of these need to be actively harmful in the way the immune system imagines. They only need to contain the right molecular features, meet the wrong immune context, and arrive in a body inclined towards sensitization. Then there is the curious unevenness of allergy between people. One person can sit in a meadow in spring looking serene and poetic, while another looks like they have been emotionally devastated by grass. This difference reflects all the variables we have been tracing: genes, barrier health, microbial exposure, early life immune education, timing of first encounters, local inflammation, prior sensitization, and the broader balance of immune regulation. The body is not issuing universal verdicts on pollen. It is issuing personal ones based on its own history. In that sense, every allergy is a story of immune biography, and biographies can change. Some children outgrow certain food allergies. Some adults develop allergies later in life. Some people become less reactive with successful immunotherapy. Others become more reactive after repeated exposures or ongoing inflammation. This flexibility is both frustrating and hopeful. Frustrating because it means the immune system is not fixed in a perfectly predictable way. Hopeful because it means immune responses can be retrained, at least to some extent. Mistaken identity can sometimes be corrected, though the process is careful and often slow. The immune system is capable of learning the wrong lesson, but that also implies it is capable, under the right conditions, of learning better ones. There is a kind of sad comedy in all this. The body, in trying to defend you, sometimes chooses the wrong suspect with absolute confidence. It meets a grain of pollen and behaves like a detective who has solved the case too early and now refuses all new evidence. The nose floods, the eyes water, the skin flares, the throat objects. The whole performance is built on certainty without wisdom, but certainty without wisdom is not unusual in biology. Speed often wins over subtlety, especially in systems shaped for survival rather than serenity. Even so, the mistake is not meaningless. The body is not broken in a chaotic sense. It is following recognizable pathways. Barrier cells, dendritic cells, T helper cells, B cells, IgE, mast cells, basophils, eosinophils, cytokines, all are participating in a pattern that has logic even when misapplied. That is the quiet comfort in understanding allergy. The body is not inventing misery for sport. It is using an ancient defense program with the wrong trigger. It sees an intruder where there is only pollen, a problem where there is only dinner, an attack where there is only a cat sleeping very confidently on a sofa. And once that mistaken recognition has happened, once the harmless thing has been classified as dangerous and the mast cells have been armed with IgE, the next encounter can unfold very quickly, because the body no longer needs to decide what it thinks. It believes it already knows, and that is when the chemical storm begins, when histamine and other mediators are released in force and the local tissues start changing almost at once. There is a particular speed to allergic reactions that makes them feel almost theatrical. One moment, everything is ordinary, the air is just air, the room is just a room, the meal is just a meal. Then, almost without warning, the body changes its tone. The nose tingles, the eyes begin to water, the skin prickles, the throat feels odd. A cough appears. A sneeze arrives with the conviction of something that has been waiting impatiently backstage for its cue. That sudden shift is one of the clearest signs that the body is not building the response slowly from nothing. It is releasing something it had already prepared. Histamine, stored away in mast cells and basophils, is one of the fastest and most important of those signals. And when it floods a local tissue, or in more serious cases spreads more widely through the body, the effects can unfold with startling speed. To understand that moment properly, it helps to go back to the mast cell sitting quietly in the tissue coated with IgE antibodies that were produced during earlier sensitization. The cell has been armed in advance. It is not guessing, it is waiting. Then the allergen appears again. A pollen protein lands in the nose. A peanut protein is absorbed in the gut. An insect sting introduces venom into the skin. That allergen binds to the IgE molecules on the mast cell surface and cross-links them, connecting multiple receptors at once. This cross-linking is the key that tells the cell the threat has returned. Not maybe, not perhaps. In the molecular language of the cell, this looks definitive, and with that the mast cell activates. Activation is not a vague event, it is a physical intracellular cascade. receptors cluster, signalling pathways inside the cell turn on, calcium levels shift, enzymes activate, the cell reorganizes itself in preparation for release. Then comes degranulation, the moment when the granules inside the mast cell fuse with the cell membrane and spill their contents outward into the surrounding tissue. Histamine is one of the first major players to rush out. This is not a slow leak, it is rapid discharge. The cell, having been told there is danger, answers by opening packets of concentrated chemical instruction directly into the place where the allergen was found. What happens next depends on where that histamine lands, how much is released, and what other mediators are being released alongside it. Histamine does not simply drift around hoping for the best. It binds to receptors on nearby cells, especially E1 receptors in many allergic tissues, and those receptors begin changing how the tissue behaves. Blood vessels widen, tiny vessels become leakier, smooth muscle may tighten, glands increase secretion, sensory nerves become stimulated. The result is a cluster of symptoms that often appear so quickly they feel like magic, or more accurately, like the body has suddenly become offended by reality. In the nose, histamine has a remarkably efficient way of making life inconvenient. The lining of the nasal passages is rich in blood vessels, glands, and sensory nerves. When histamine is released there, the small blood vessels dilate and become more permeable. More blood arrives, more fluid escapes into the tissue, the lining swells. That swelling narrows the space through which air can pass, leading to congestion, that peculiar sensation of having a face full of airways and none of them being cooperative. At the same time, glands in the nasal lining produce more mucus, and fluid leaks into the nasal passages. This creates the classic runny nose, not because the body enjoys the drama, but because it is trying to flush away what it believes is an invader. Add histamine's action on sensory nerves, and now the nose tingles, itches, and prepares to sneeze. Sneezing itself is a useful example of how quickly a chemical signal can become a full-body action. Histamine irritates sensory nerve endings in the nasal mucosa. Those nerve signals travel to brainstem centers that coordinate the sneeze reflex. A deep breath, closure of the eyes, pressure building in the chest, then a forceful explosion of air through the nose and mouth. It is, in essence, a high-speed biological expulsion mechanism. Crude? Yes. Elegant? Not especially. Effective? Often. The body is trying to eject the problem by force. The fact that a single speck of pollen can trigger repeated sneezes only highlights how enthusiastic the system can be once histamine and its allies have entered the scene. The eyes respond in a similar spirit. Their surfaces are delicate, exposed, and richly supplied with vessels and nerves. When histamine is released around the conjunctiva, the thin membrane covering the white of the eye and inner eyelids, blood vessels widen and the area reddens. Fluid movement increases, tissues become puffy, and the lacrimal glands may contribute to excessive tearing. The eyes itch, perhaps most cruelly of all, because itching in the eye occupies that special category of human suffering in which relief is always a little inappropriate and never quite enough. The watery eyes are not tears of emotional devastation, though during peak pollen season one could be forgiven for misreading the expression. They are part of a defensive wash, another attempt to dilute and remove what the body thinks should not be there. On the skin, histamine's effects can be especially visible. A local release produces redness because blood vessels widen. Swelling follows because fluid leaks into the tissue. Sensory nerves generate itching. If the reaction is focal, the result may be a wheal and flare response, a raised pale bump surrounded by redness, as in a hive or a reaction to an insect bite. The wheal represents swelling from fluid leakage, while the flare reflects increased blood flow. This response can appear within minutes. It is one of the clearest demonstrations of histamine's power to transform tissue rapidly. Something as simple as brushing against an allergen or being stung by an insect can produce a visible map of immune alarm on the skin almost immediately. the lungs and airways are where histamine's effects can become more serious. In susceptible people, especially those with allergic asthma, histamine can contribute to bronchoconstriction, the tightening of smooth muscle around the airways. It also promotes swelling and mucus production in the airway lining. Put those together and airflow becomes more difficult. Breathing may become wheezy, tight, or laboured. A person may cough, feel chest pressure, or sense that their breath no longer moves with its usual ease. The airways, after all, are another border tissue, and the same logic applies. Narrow the passage, increase secretion, defend the surface. Reasonable in principle, potentially dangerous in practice. A defense strategy is only useful if it does not compromise the very breathing it is meant to protect. In the gut, histamine can help create a different kind of chaos. The digestive tract is full of smooth muscle, glands, blood vessels, and immune cells. When an allergen enters there and triggers mast cell activation, histamine and other mediators can increase fluid secretion, alter motility, and contribute to swelling and discomfort. The result may be cramping, nausea, vomiting, diarrhea, or an uneasy sense that the body has deeply regretted the meal. Again, the underlying logic is not mysterious. Increase movement, clear contents, respond quickly to what is perceived as danger. The body is attempting removal. It is just doing so in a way that makes dining considerably less relaxing. All of this describes local release, where histamine is acting mainly near the site of allergen exposure. But in some reactions, the release becomes broader and more systemic. This is when the situation becomes much more serious. If enough mast cells and basophils degranulate across multiple tissues, or if the trigger reaches the body in a way that leads to widespread activation, histamine and other mediators can affect blood vessels throughout the body. Vessels dilate more generally. Capillary permeability rises in many places at once. Fluid shifts out of the bloodstream and into tissues. Blood pressure may fall. Swelling can occur in deeper tissues, including the throat. Airway narrowing may intensify. The heart may race in compensation. The person may feel faint, flushed, panicked, or suddenly very unwell. This is no longer just a local false alarm. It is a systemic emergency. The remarkable thing is that histamine can help explain much of that cascade, yet it is rarely acting alone. When mast cells degranulate, they also release tryptase and other granule contents. Soon after, they begin generating leukotrienes and prostaglandins, which can prolong and intensify bronchoconstriction, vascular changes, and inflammation. Cytokines follow, helping recruit other immune cells and shape later phases of the response. Histamine is the fast opening act, the chemical that makes the first changes visible and felt. But it is joined quickly by a broader inflammatory orchestra, and that is why a reaction can evolve over time rather than ending the moment the first sneeze has happened. This layered process explains why someone may feel an immediate rush of symptoms and then continue to worsen or remain inflamed for hours. The early phase, often within minutes, is dominated by preformed mediators like histamine. The late phase, arriving later, reflects recruitment of other cells, especially eosinophils and T cells, and the continued influence of newly produced mediators. In allergic rhinitis, this can mean the sneezing and itching start fast, while congestion and tissue irritability continue much longer. In asthma, the initial bronchoconstriction may be followed by sustained airway inflammation. The first flood of histamine opens the story, but it does not write the whole thing. One of the reasons histamine feels so immediate is that it acts on nerve endings as well as vessels and glands. This gives allergy symptoms their sensory sharpness. The itch is not abstract. The tickle in the throat is not imagined. The tingling in the nose is not poetic. Histamine is literally helping certain nerves fire in ways that call attention to the affected tissue. In a sense, the body is broadcasting. Something is happening here. Notice it. Respond. Scratch. Blink. Cough. Sneeze. Pull away. Do something. For an immune system concerned with border defense, this is useful. For a person trying to sit quietly through spring, it is less welcome. There is also an important difference between histamine's effects and the way we experience them. From a biological perspective, histamine is creating vascular and cellular changes. From a human perspective, it feels like the body has decided to become difficult. Congestion feels heavy and dull. Itching feels maddeningly specific. Hives feel dramatic. A runny nose feels almost comically relentless. These are subjective experiences layered over objective tissue changes. That matters because allergic reactions are often dismissed as minor, partly because the triggers seem harmless. But the sensations produced by histamine are entirely real, and in severe cases the consequences are not minor at all. The speed of the reaction can also be emotionally unsettling. There is something unnerving about the body changing so quickly in response to a tiny amount of material. It can make the outside world feel unpredictable. A meal, a garden, a pet, a medication, a sting. All can seem ordinary until the body responds with alarming confidence. That confidence comes from sensitization and the preloaded state of the mast cells. The body has already decided this substance matters. Once the allergen appears again, the release is swift because the preparation was done earlier. The cell has been waiting, armed and certain. This rapid certainty is why antihistamines can be so useful for many allergic symptoms. By blocking histamine receptors, especially H1 receptors, they can reduce the tissue's ability to respond to histamine once it is released. They do not usually stop the mast cell from degranulating in the first place, and they do not erase the immune system's mistaken memory, but they can soften the consequences. The vessels dilate less, the nerves itch less, the glands secrete less. The body's false alarm is still being sounded, but the volume is turned down. It is a practical strategy, though not a full correction of the underlying error. Even with treatment, however, the body's sequence is worth appreciating because it reveals the logic beneath the discomfort. Histamine is released because a sentinel cell has been told that a recognized threat has returned. The release is fast because speed is valuable in true defense. The symptoms occur because histamine changes vessels, nerves, glands and muscles in very concrete ways. The body is not behaving randomly. It is following a program that is ancient, powerful, and only sometimes unfortunate enough to be aimed at pollen or peanuts, instead of something more deserving. There is perhaps a grim sort of admiration to be had for the efficiency of it. A microscopic interaction at the cell surface leads in moments to sneezing, swelling, mucus, redness, itching, tightness, coughing, tears, or cramps. Few systems in the body turn molecular recognition into full sensory drama quite so quickly. It is rather like watching one tiny clerical error in a large institution accidentally trigger every alarm, sprinkler, and emergency light in the building all at once. Wasteful for a harmless trigger, certainly, but impressive as a demonstration of infrastructure. And because histamine acts differently depending on the tissue, the visible shape of the reaction begins to tell you something about where the flood has happened and how the local environment has answered. A nose full of congestion is one expression of histamine. Hives are another. Wheezing is another. Watery eyes, swelling lips, abdominal pain. These two belong to the same underlying chemistry, translated into the language of different organs. The body does not have one universal allergy symptom. It has many local dialects of the same alarm. That is why the next step in the story is so important. Because once histamine is released and the tissues begin their immediate responses, the reaction starts to take on recognizable forms, becoming the itch, the swell, the sneeze, the wheeze, the rash, and the watery eyes that people know so well, each one a specific expression of how allergic chemistry plays out in different parts of the body. What makes allergic symptoms so peculiar is not only that they appear quickly, but that they feel so specific. An itch is not vague discomfort, it is demand. A sneeze is not a gentle suggestion, it is a full-body announcement. Swelling is not merely a change in appearance, it is the tissue itself becoming altered, fuller, tighter, heavier, and sometimes alarmingly unfamiliar. By the time a person notices these symptoms, the chemistry we have been tracing is already well underway. Histamine has been released, receptors have been activated, blood vessels have changed their behaviour, nerves have started firing differently, glands have begun to produce fluid, muscles may be tightening. The immune system's false alarm is no longer just molecular. It has become physical, sensory, and impossible to ignore. That is part of why allergic reactions are so memorable. Many bodily processes are quiet. Digestion goes on without demanding applause. Hormones drift about their business unnoticed. Even immune activity is often hidden unless there is fever, pain, or fatigue. Allergies, by contrast, are often immediate and theatrical in a way few other common conditions manage. The body does not merely register the allergen, it puts on a performance. The nose runs, the eyes water, the skin rises in welts, the throat feels strange, the chest tightens, and somewhere in the middle of all this, the person involved is expected to continue acting normal, which is a great deal to ask of anyone who has just sneezed 6 times in a row and can no longer remember what breathing through one's nose used to feel like. Still, the drama has structure. Allergic symptoms do not appear as a random set of inconveniences pulled from a hat. They arise because the same small group of tissue changes can produce several familiar effects. Histamine widens blood vessels. It makes tiny vessels leakier. It stimulates sensory nerves. It encourages glandular secretion. It can influence smooth muscle. Other mediators released alongside it add to the pattern. Once you understand those basic actions, the classic symptoms begin to make sense. The itch, the swell, the sneeze, the tears, the mucus, the wheeze, they are not separate mysteries. They are related outcomes of the same defensive program being activated in the wrong setting. Take itching first, because it is one of the clearest and most maddening symptoms of all. Itching happens when certain sensory nerve endings in the skin or mucous membranes are stimulated in ways that send a very particular message to the brain. Histamine is especially good at triggering that message. It binds to receptors that influence these nerves, and the result is a sensation that is neither pain nor touch nor temperature, but something with its own irritating identity. An itch demands attention. It invites action. Scratch here, rub this, blink, reach for the skin, do something. This is not accidental. The body uses itch as a way of making sure you notice a local problem. If something small has landed on the skin, burrowed into it, stung it or irritated it, itch helps direct awareness to the spot. That makes sense in a world full of insects, parasites, rough plants and environmental hazards. It makes less sense when the trigger is a harmless protein drifting through the air, yet the system does not care much for that distinction. Once mast cells have been activated, histamine stimulates those nerves anyway. The skin itches, the eyes itch, the inside of the nose itches, which is one of the more oddly specific and deeply annoying experiences available to the human face. There is a reason people with allergies often rub their noses upward or keep touching their eyes. The sensory signal is strong and persistent because the body is trying to force awareness of a problem it has badly misidentified. Scratching, of course, is a mixed blessing. It can briefly reduce the sensation by interrupting the nerve signaling with a competing sensation, often mild pain or pressure, but it can also make things worse. Scratching irritated skin can damage the barrier further, increase local inflammation, and release more signals that keep the cycle going. The same is true of rubbing the eyes. Relief comes for a moment, then redness, irritation, and swelling often become more obvious. This is one of the small cruelties of allergic symptoms. The body sends a signal that demands a response, then punishes the response if you obey too enthusiastically. It is a bit like an alarm clock that asks to be hit and then complains about the impact. Swelling is another key symptom, and it arises from a different side of histamine's work. When histamine acts on blood vessels, especially the tiny ones near tissue surfaces, it causes them to dilate and become more permeable. Dilating means opening wider, allowing more blood to flow into the area. Increased permeability means fluid, and small proteins can slip out of the circulation into the surrounding tissue more easily. That extra fluid in the tissues produces edema, which is the medical word for swelling. This can happen in the skin, the lining of the nose, the lips, the eyelids, the throat, and many other places depending on where the reaction is happening. The interesting thing about swelling is that it is both useful in principle and unpleasant in practice. From the immune system's point of view, allowing fluid and immune components to move into a tissue can help bring defenses closer to the site of trouble. It can dilute harmful material, support inflammation, and make it easier for immune cells to leave the bloodstream. From the person's point of view, it means puffy eyes, blocked nasal passages, raised hives, thick lips, or tissue that feels suddenly tight and wrong. The biology is trying to create access and action. The sensation is that your own face has become less willing to cooperate with social life. In the skin, this swelling often appears as hives, also called urticaria. These are raised, itchy welts that can appear quickly and then move or fade over time. Each hive reflects a local patch of vessel leakage and swelling in the upper layers of the skin, usually surrounded by redness from increased blood flow. Hives can be small or large, few or many, and they often seem to have a mischievous sense of timing. They arrive fast, itch intensely, and may vanish from one spot only to appear somewhere else. That shifting quality can feel mysterious, but it reflects the local nature of mediator release and tissue response. One area swells, then calms, while another becomes active. Deeper swelling can also happen and is often called angioedema. This affects tissues beneath the surface, including the lips, eyelids, hands, feet, or deeper structures of the face and throat. Unlike hives, angioedema may be less itchy and more heavy, stretched, or painful. When it involves the mouth or throat, it can be especially concerning because swelling there can interfere with normal breathing or swallowing. Again, the mechanism is largely about vessel permeability and fluid movement, but the location determines the seriousness. A raised patch on the arm is bothersome. Swelling in the airway is something else entirely. Then there is the sneeze, which might be the most famous allergic symptom purely because it is so public. Sneezing begins with irritation of sensory nerves in the nasal lining. Histamine helps trigger that irritation, but so do other inflammatory substances and the physical presence of mucus or particles. Once those sensory signals reach the right reflex centres, the body prepares a sneeze, a breath is drawn in, muscles coordinate, pressure builds, then comes a sudden explosive release of air through the nose and mouth. The goal is simple: expel whatever is irritating the upper airway. It is a mechanical clearing strategy, as old and direct as biology gets. Sneezing may look comic from the outside, especially when it comes in rapid bursts, but its logic is serious. The body is trying to remove a perceived threat from a vulnerable border surface. Histamine has already increased secretion and irritated nerves. The sneeze reflex turns that irritation into force. This is why allergies often produce repeated sneezes rather than one tidy, dignified example. The local tissue remains inflamed, mucus is present, nerves stay sensitive, the body keeps trying to clear what it thinks is there. Unfortunately, pollen and dust do not always leave because of one enthusiastic outburst, so the cycle may continue until exposure falls or the chemical signalling is reduced. Closely tied to the sneeze is the runny nose, or rhinorrhea, which is less dramatic but often more persistent. Histamine stimulates glands in the nasal lining and increases fluid leakage from blood vessels, which adds watery secretions to the nasal passages. At first, the discharge may be quite thin and clear because it is largely fluid. Later, as inflammation continues and mucus production increases, it may feel thicker or more obstructive. The body is trying to wash the surface, trap particles, and move them out. From a defensive standpoint, that is sensible. From a practical standpoint, it means tissues in every pocket, and the growing suspicion that one's nose is now the most committed producer in the household. Congestion follows from the swelling side of the same process. Inside the nose are structures rich in blood vessels and soft tissue that can swell considerably when inflamed. Histamine increases blood flow and leakage there, narrowing the airway spaces. That is why an allergic nose can feel blocked even while it is also dripping. It seems contradictory, but it is not. One part of the system is producing fluid into the airway, while another part is swelling the tissue around it. The result is the peculiar misery of feeling both too full and too leaky at the same time. Very few biological states capture inconvenience with such efficiency. Watery, red, itchy eyes develop for similar reasons. Histamine acts on the vessels of the conjunctiva, causing them to widen and become leakier. The eyes redden because more blood is flowing through those tiny vessels. The tissues puff because fluid moves outward. Nerve endings create itching and irritation. Tearing increases in an effort to rinse the surface. This, again, is local defense translated into symptom. The eye is exposed, delicate, and worth protecting. The body would rather over-rinse it than ignore a possible threat. The result, however, is that a person with allergic conjunctivitis may look emotionally fragile while actually being immunologically overcommitted. The throat can also become involved, though the sensations vary. Some people notice itching or tingling in the throat or roof of the mouth, especially with inhaled allergens or certain foods. Others experience cough, which can be triggered by postnasal drip, airway irritation, or increased sensitivity of the upper airways. That throat-clearing cough people often do during allergy season is sometimes the body's answer to mucus and irritation higher up rather than a primary lung problem. The tissues are inflamed, the nerves are aware, and the reflexes are being invited to contribute. Histamine does not act alone here, but it helps create the local environment in which those symptoms become likely. When the lower airways are involved, the symptoms change character. Wheezing, chest tightness, shortness of breath, and coughing point toward bronchial involvement. Histamine can contribute by causing smooth muscle contraction in the airways and by promoting swelling and mucus production. The narrowed airway becomes harder to move air through, especially during exhalation, which is why wheezing is often heard on the way out. For someone with allergic asthma, this is one of the most burdensome effects of the allergic response because breathing changes quickly, from something automatic and invisible into something noticed and effortful. The defensive logic is once again poor consolation. The body may think it is protecting the airway surface, but if the tube carrying the air narrows too much, protection starts looking remarkably like sabotage. Timing also shapes how these symptoms develop. The earliest symptoms, especially itching, sneezing, flushing, and watery secretions, are often tied closely to immediate histamine release. They can begin within minutes. Swelling and congestion may follow quickly and persist longer, because the tissue changes do not vanish the moment the first mediator levels begin to fall. Then there is the later wave, when other inflammatory cells and mediators arrive. That is why someone can start with sneezing and itching, and then spend hours feeling blocked, heavy, or reactive. The first signal opens the door. Other parts of the immune response come in after it and make themselves comfortable. This layered pattern matters because it explains why the body can feel different at different stages of the same reaction. Early on, the symptoms may be sharp and noticeable in a sensory way. Later, they may be duller but more persistent. The itch may ease while congestion worsens. The sneezing may stop while the swelling remains. A rash may flatten while the skin still feels irritable. Histamine is central to the opening phase, but it sets off processes that continue beyond its first burst. Allergic symptoms take shape over time, even if the first outline is drawn very quickly. Another reason allergic symptoms vary is that different people have different tissue sensitivities. One person's nose may be the main battlefield. Another's skin responds more dramatically. Another's lungs or gut are more involved. The immune signal may be similar at the start, but the body translates it through the tissues most vulnerable, most exposed, or most primed to react. This is why two people can encounter the same allergen and seem to have completely different experiences. One reaches for tissues, Another breaks out in hives. Another feels their chest tighten. The underlying biology overlaps, but the visible symptom pattern depends on where the reaction takes hold and how that tissue behaves when histamine and its companions arrive. There is also a small but important point about why these symptoms feel so personal. They involve border tissues, the very places where the outside world meets the self, the skin that touches clothing and air, the eyes that face dust and pollen, the nose that greets every breath, the lungs that trust the atmosphere, the gut that receives food. When these tissues react, the body's relationship with ordinary life is interrupted. Walking outside, eating dinner, hugging a pet, even lying down to sleep can all feel different. Allergy symptoms are not merely physical signals. They are changes in the experience of living through the body from one moment to the next. And because these symptoms are built from recognizable biological tools, they can often be softened by targeting those tools. Antihistamines reduce some itching, sneezing, and watery secretions by blocking histamine's action. Nasal sprays can reduce local inflammation. Bronchodilators can open narrowed airways. Other medicines interfere with leukotrienes or calm the immune response more broadly. Treatment works not because symptoms are mysterious, but because they follow pathways that can be understood and interrupted. The body may be running the wrong program, but it is still a program. That is the quiet lesson beneath the itch, the swell, and the sneeze. These symptoms are not random punishments. They are the visible shape of the immune system's mistaken certainty. Histamine has touched nerves, vessels, glands, and muscles. Tissues have answered in the ways they know how. The nose tries to flush, the skin tries to signal, the eyes try to rinse, the airways try to protect themselves. The body is acting out an ancient script designed for real intruders, and it is doing so with embarrassing seriousness in response to harmless things. Once those symptoms begin to take shape, the next piece of the story becomes clearer, because the same general chemistry can look very different depending on where it lands, and a reaction in the nose does not unfold quite the same way as one in the skin, the lungs, or the gut. One of the more confusing things about allergies is that they do not pick a single style and stick with it. If the body were at least consistent, you might say, right, I see, this is the part where it overreacts, and from now on it will always do so in this one predictable way. But that is not how it works. One person breathes in pollen and starts sneezing like a Victorian with strong opinions about spring. Another touches the wrong thing and breaks out in raised itchy welts. Another eats a food their immune system dislikes and feels their stomach twist into protest. Another meets a trigger through the air and their chest tightens, until breathing itself feels suddenly less automatic than it ought to be. Same broad problem, same general immune style, many different outcomes. That variation is not random. It happens because the body does not react in the abstract. It reacts in tissues, and different tissues are built differently, exposed differently, and tasked with different jobs. The immune alarm may follow familiar rules, but each part of the body speaks that alarm in its own dialect. This is one of the most useful ideas to hold on to when trying to understand allergies. The immune system is not dropping the same symptom into every part of the body like identical parcels. It is setting off a set of signals, histamine and other mediators among them, and those signals interact with whatever local tissue happens to be involved. The nose has one structure, the skin has another. The lungs and gut are built for completely different purposes. Their blood vessels behave differently, their glands behave differently, their nerves, muscles, and barrier cells behave differently. So when mast cells release histamine and the surrounding immune response gets going, the result depends very much on the landscape in which it happens. An allergic reaction in the nose becomes one thing. The same general immune style in the skin becomes another. In the lungs, it can become something much more serious. In the gut, it becomes yet another kind of disturbance altogether. The body, after all, is not one uniform surface with interchangeable plumbing. It is a collection of specialized environments. Barrier tissues are especially important here because they are the places where allergens most often enter. The inside of the nose is a moist, highly vascular airway surface designed to filter, warm and humidify air. The skin is a layered protective barrier designed to keep the outside out and the inside in. The lungs are delicate branching air passages ending in tiny sacs where oxygen has to move into the blood with extraordinary efficiency. The gut is an enormous absorptive surface that must welcome food while deciding constantly what to tolerate and what to reject. All of these are border zones, but they are not the same border. They are like different kinds of gates in the same city, each with its own architecture, guards and vulnerabilities. So when the immune system becomes suspicious, the symptoms reflect the gate involved. Let us start with the nose, because it is one of the most common battlefields and perhaps the most publicly inconvenient. The nasal passages are lined with a mucous membrane rich in blood vessels, glands, sensory nerves and immune cells. They are also full of folds and structures designed to create airflow patterns that help trap particles before they go deeper into the respiratory tract. This is all useful, but it also means the nose is a wonderfully reactive place. When pollen, dust mite particles, mold spores or animal dander arrive there and meet an immune system already sensitized to them, mast cells in the lining can release histamine very quickly. The blood vessels widen, the tissue swells, glands produce more fluid, and sensory nerves become irritated. The result is the familiar trio of itching, sneezing, and congestion, often accompanied by a runny nose so committed to its job that it begins to feel like an independent weather system. The nose reacts this way because its normal function is to deal with incoming material actively. It filters, moistens, traps, and moves things along. So when the immune system mistakes a harmless allergen for a genuine threat, the nose responds using the tools it already has. More mucus helps trap and clear particles. Swelling alters the local tissue environment and increases blood flow. Sneezing forcefully expels what should not remain. From the body's perspective, this is sensible. From your perspective, especially if this is happening during a conversation, a commute, or a quiet attempt to sleep, it is less impressive. Still, the symptoms match the organ. The nose's version of alarm is built around fluid, irritation, and expulsion, because that is what the nose is structurally able to do. The eyes often join in because they share exposure to the same airborne world and have similarly delicate surface tissues. Their response overlaps with the nose but has its own flavour. The conjunctiva is thin, vascular, and easily irritated. Histamine released there causes redness, itch, tearing, and puffiness. Again, these symptoms are not arbitrary. The eyes cannot sneeze, which is probably wise, but they can flush, water, and signal intensely through itching. They are trying to rinse and protect a very sensitive surface. That is why someone with hay fever can look as though they have been up all night watching tragic cinema, when in reality they have merely walked past a tree at the wrong time of year. The skin is a different sort of battlefield entirely. It is dry on the outside, layered, and designed above all to be a barrier. It keeps water in, blocks microbes and irritants out, and constantly renews itself. When the skin participates in allergic reactions, the visible result often looks very different from what happens in the nose because the skin structure and role are different. Histamine released in the skin acts on local blood vessels and nerves, causing redness, swelling, and itching. The classic fast allergic skin reaction is the hive, a raised, itchy wheal surrounded by flare, produced by local leakage of fluid and increased blood flow. Hives can come and go quickly, because the skin's vessels and mast cells can create these patches in one place, and then settle while another patch develops elsewhere. But the skin has another story to tell in allergy, especially when its barrier is disrupted over time. Conditions like eczema involve more than a quick burst of histamine. They reflect chronic inflammation, barrier dysfunction, immune activation, dryness, and intense itching that can persist. Here the battlefield is not just reacting to an incoming allergen with a sudden splash of mediator release. It is damaged ground, repeatedly irritated, allowing more substances to penetrate and more immune activity to continue. That is why allergic disease of the skin can look so different from a simple hive. One is a rapid local swelling response. The other can become a longer, more layered condition of barrier weakness and inflammation. Same immune tendencies, very different terrain. The skin's nerves also make itching central in a way that is hard to overstate. Histamine is especially good at provoking itch in the skin, and once scratching begins, the barrier can be damaged further, leading to more inflammation and more itch. It becomes a loop, one of the less charming loops in human biology. The skin is always in contact with clothing, heat, sweat, soaps, dry air, fabrics, pets, and the endless little frictions of daily life. So when it becomes an allergic battlefield, there are many ways for the irritation to be fed. The skin cannot sneeze out its problem, and it cannot simply wash it away with tears. Instead, it reddens, swells, and itches, which is the skin's deeply persuasive way of saying that all is not well at the border. The lungs, meanwhile, are a more delicate and more dangerous battlefield because their job is so essential, and their structure is so fine. Air must travel through branching tubes that become smaller and smaller, eventually ending in tiny alveoli where oxygen crosses into the blood and carbon dioxide leaves it. This is an extraordinary design, but it depends on those airways remaining open enough for air to move. When allergy affects the lungs, especially in allergic asthma, the problem is not just irritation. The airways themselves become reactive. Histamine and other mediators can cause smooth muscle around the airways to contract. The lining swells, mucus increases, the tubes narrow, breathing becomes harder. This is where tissue differences matter greatly. The nose can swell and still be annoying rather than life-threatening. The skin can develop welts and still keep doing its job reasonably well. The lungs have far less margin for that kind of indulgence. A narrowed airway immediately affects airflow. That is why the same basic immune style can feel minor in one organ and alarming in another. In the lungs, allergic inflammation becomes wheezing, coughing, chest tightness, and shortness of breath because the organ is made of narrow passages and delicate gas exchange surfaces. Its version of defense, if misdirected, can obstruct the very breathing it is meant to protect. The lungs are also highly innervated and closely connected to reflexes involving cough and airway tone. So when inflammatory mediators are released there, the body does not merely notice, it changes breathing behaviour. The person may feel they cannot fully exhale, or that a band has been tightened around the chest. That sensation is specific to the organ involved. Histamine is part of the early chemistry, but leukotrienes and other mediators are also especially important in airway reactions, helping explain why allergic asthma can be persistent and serious. Once again, the organ shapes the expression. The immune system supplies the alarm. The lungs turned it into narrowed airways and difficult breaths. The gut may be the strangest battlefield of all, partly because it has to do something biologically very unusual. It must allow the outside world in. Food is external material entering the body through a long internal tube, and the immune system must constantly decide what to ignore, what to tolerate, and what to oppose. Most of the time, this works remarkably well. We eat without drama. The gut digests, absorbs, and negotiates peace with countless proteins and microbes. But when food allergy or other allergic type reactions involve the gut, the symptoms reflect the gut's own defensive toolkit. Smooth muscle contraction, increased secretion, fluid shifts, swelling, altered motility, nausea, vomiting, cramps, diarrhea. These are the gut's ways of saying no, absolutely not. This should leave immediately. That response makes primitive sense. If something harmful has been eaten, speeding movement, increasing fluid, and ejecting contents upward or downward could be useful. The problem, of course, is that in allergies the offending item may be perfectly harmless to most people. Still, the gut does not care about majority opinion. If mast cells in the intestinal lining are activated and mediators are released, the bowel can become crampy and urgent very quickly. The muscles contract more, secretions increase, blood flow changes, the person may feel sick, bloated, painful, or as though their digestive system has taken sudden personal offence to dinner. The gut is also interesting because it is where tolerance should be strongly taught. When that tolerance fails or is bypassed, the consequences can be systemic. Food allergens absorbed through the gut can trigger local symptoms there, but they can also lead to more widespread reactions affecting the skin, lungs, and circulation. This helps explain why foods are such important causes of serious allergic emergencies. The gut is not just a local battlefield, it can be an entry point from which the immune alarm spreads. By contrast, a little pollen trapped in the nose may stay a largely nasal problem. The route of exposure changes the scale as well as the symptoms. Another important reason these tissues behave differently is that their mast cells are not identical in every respect. Mast cells mature under local tissue influences, and the immune environment of the skin is not the same as that of the lung or intestine. Different tissues produce different supporting signals, have different resident cells, and are exposed to different physical conditions. So a mast cell in the skin lives one kind of life, while one in the gut lives another. They are part of the same family, but they operate in neighbourhoods with different rules. That affects what other mediators are released, which immune cells are recruited, and how the inflammation unfolds over time. The barrier itself also matters enormously. A healthy skin barrier helps keep irritants and allergens from penetrating deeply. A healthy nasal lining traps particles and clears them effectively. A healthy airway lining protects the lungs from inhaled material. A healthy intestinal barrier decides, very carefully, what gets absorbed. When these barriers are disrupted, allergens may gain access in ways that encourage more immune attention. A dry, cracked, eczema-prone skin barrier invites trouble of one sort. An inflamed nasal lining during pollen season becomes more reactive to repeated exposure. Airways already irritated by viral infection or pollution may respond more strongly to allergens. A gut influenced by infection, inflammation, or altered microbiota may process exposures differently. The battlefield is not only defined by the invading substance, but by the condition of the wall it meets. Nerves too differ across these organs, and that changes the feel of the reaction. In the nose, irritated nerves lead to sneezing and itching. In the skin, they produce intense itch and the urge to scratch. In the lungs, nerve-related reflexes can contribute to cough and bronchospasm. In the gut, nerve and muscle interactions create cramps, nausea, and discomfort. Histamine is part of these sensory experiences, but the organ determines how those sensations are translated into action. The body is not merely inflamed, it is reacting through local reflexes and local tissue behaviours. The same signal in different places creates very different kinds of misery. Blood vessels also behave according to local design. The skin can show flushing and hives because its surface vessels are so visible and accessible. The nasal passages can become dramatically congested because their tissue is full of expandable vascular structures. The lungs are less visibly red, obviously, but vascular changes there contribute to swelling and inflammation in ways that matter greatly for airflow. The gut may not display its vascular drama in a mirror, but fluid shifts and local swelling there are very much part of the distress. The chemical language overlaps, but the visible translation depends on the organ's architecture. Then there is function. Each organ has something vital it normally does, and allergic symptoms often reflect disruption of that normal function. The nose is meant to conduct and condition air, so allergy there becomes blockage, dripping, and sneezing. The skin is meant to be a barrier, so allergy there becomes leakage, inflammation, and itch. The lungs are meant to move air freely, so allergy there becomes narrowing and breathlessness. The gut is meant to digest and absorb, so allergy there becomes cramping, expulsion, and refusal. The symptoms are, in a sense, the organ's normal job gone defensive and unhelpful. This is why one person's allergies can seem almost trivial to another who experiences them in a different tissue. A person with mild seasonal rhinitis may feel miserable but remain safe. A person with food-triggered airway swelling or asthma is in a different situation altogether. A person with chronic eczema lives with an exhausting skin barrier problem that may not be dramatic in the moment but can shape daily life profoundly. The immune system may be playing variations on the same theme, but the battlefield determines the stakes. It is also why treatments differ by organ. Antihistamines may help the nose and skin quite a lot, especially with itching, sneezing and hives. Nasal steroid sprays are useful because they calm local inflammation where it starts. In asthma, inhaled medications are aimed directly at the airways to reduce inflammation and open them. In eczema, moisturizers and barrier repair are as important as immune control because the battlefield wall itself needs mending. In food allergy, strict avoidance and emergency preparedness become central because the gut can be the doorway to something systemic and severe. Understanding where the reaction is happening changes not just how it feels, but how it is managed. There is something almost poetic, though not in the dreamy sense, about the fact that each organ reacts according to its nature. The nose tries to flush and eject. The skin tries to signal and wall off. The lungs tighten and guard their passages. The gut churns and rejects. None of them are inventing new tricks for allergy. They're using their old ones, just too eagerly and against the wrong target. That is what makes allergic disease feel both coherent and varied at once. The immune system supplies the suspicion, the tissue supplies the style, and of course, sometimes these battlefields do not stay separate. A food allergy can begin in the gut and then spread to the skin, lungs and circulation. Airborne allergens can affect the nose and eyes together. A person with the so-called atopic pattern may carry eczema, allergic rhinitis and asthma across different stages of life, each organ taking its turn in the story. The body is one connected system after all. Separate battlefields, yes, but the same nervous system, bloodstream, immune memory and inflammatory language. What begins locally can sometimes widen, and what seems mild in one tissue can become something far more serious when the response spills across many at once. That widening is the next thing to understand, because there is a point at which the body's local false alarm stops being merely uncomfortable and begins to turn dangerous, when swelling, airway changes, and falling blood pressure move the reaction out of the territory of nuisance and into something much faster, fiercer, and far more urgent, more. Up to a point, an allergic reaction can feel almost ordinary in its inconvenience, a little itching, a runny nose, a few hives, perhaps a sensation that the body has chosen an unfortunate moment to become theatrical. But there is an important line, and once the reaction crosses it, the situation changes from bothersome to urgent. This is the moment when the body's local false alarm stops behaving like a neighbourhood disturbance and begins acting like a whole-system emergency. In medical terms, that emergency is called anaphylaxis, a severe allergic reaction that can begin suddenly, worsen quickly, and become life-threatening because the same chemical surge that causes itching and swelling can also narrow airways, drop blood pressure, and affect several organ systems at once. What makes this shift so unsettling is that it can begin with symptoms that do not seem especially dramatic at first. A strange feeling, a few hives, an itchy mouth, a bit of nausea, a runny nose. Sometimes the early signs are so ordinary that the body appears to be giving only a mild warning, but severe reactions often do not arrive with the courtesy of an obvious opening announcement. They can start with small symptoms and then progress quickly into trouble breathing, throat tightness, hoarseness, dizziness, fainting, abdominal pain, vomiting, or a sense that something is very wrong. In some cases, skin symptoms are prominent. In others, respiratory or circulatory symptoms appear first, which is one reason serious allergic reactions can be missed if people expect every dangerous reaction to look like a dramatic rash. The underlying reason the reaction becomes dangerous is not mysterious, even if it feels frightening in the moment. Mast cells and basophils have released a flood of mediators, with histamine among the fastest and most famous. and those mediators are no longer acting only in one small patch of tissue. Blood vessels may dilate more widely through the body. Their walls may become leakier, allowing fluid to move out of the circulation and into tissues. That means the bloodstream itself can begin losing volume where it matters most while the tissues become swollen. The heart tries to compensate by beating faster. If this continues, blood pressure can fall sharply, and organs may receive less effective circulation. At the same time, the airways may narrow from smooth muscle contraction and swelling, especially in the throat or lungs. The result is a reaction that is dangerous for two main reasons at once. Breathing can become harder, and circulation can become less stable. That is why the symptoms of anaphylaxis can look so varied while still belonging to the same event. One person may have hives, swelling of the lips, vomiting, and wheezing. Another may have throat tightness, hoarseness, dizziness, and a rapid weak pulse. Another may feel abdominal cramps and then suddenly become faint. Medical descriptions commonly include skin reactions such as hives and flushing, swelling of the face or throat, trouble breathing or swallowing, wheezing, nausea, vomiting, diarrhea, dizziness, fainting, low blood pressure, and rapid heartbeat. The reaction is called systemic, not because every person gets every symptom, but because more than one body system may be involved at once, or because the circulatory and respiratory effects are significant enough to make the whole body unstable. There is also a cruel unpredictability to it. People often assume that a past mild reaction guarantees future reactions will also be mild, but that is not a promise the immune system is willing to make. Public allergy guidance emphasizes that reaction severity can be unpredictable. Someone who once had only hives might later have a much more serious response, while another person's future reaction may be milder. This uncertainty is part of what makes severe allergy so emotionally heavy. A trigger is not just unpleasant, it becomes something the person must respect because the body's future behaviour cannot be forecast with perfect confidence. The immune system remembers, but it does not always repeat itself with the same volume. Sometimes it arrives quieter, sometimes it arrives all at once, like a band that was apparently told to begin in the middle of the song. Certain triggers are especially associated with severe reactions. Foods such as peanuts, tree nuts, fish, and shellfish are common examples, as are insect stings, certain medications, and latex. These triggers matter not because they are uniquely dramatic objects in daily life, but because in sensitized people, they are especially capable of setting off the chain of immune events that leads to widespread mast cell activation. Food is particularly interesting because it enters through the gut and can then affect the skin, airways, and circulation. Insect venom is different again, introduced directly into tissues. Medications may be given by mouth, by injection, or by infusion, creating different patterns of exposure. The route changes the details, but the essential problem is the same. Once the immune system decides the trigger is dangerous and enough mediator is released, the body can move from local symptoms to a systemic emergency very quickly. One of the most concerning features of serious allergic reactions is how fast they can evolve. Authoritative medical sources describe anaphylaxis as a rapidly developing condition that often occurs within minutes to an hour after exposure, and they note that the more rapid the onset and progression, the more severe the reaction may be. That speed is why people sometimes describe feeling that the body has changed all at once. The chest feels tighter, the throat feels different, the voice turns hoarse, the person becomes flushed, dizzy, panicked, or faint. It is not that the body has suddenly become irrational in a random sense. It is that the same emergency chemistry we have been tracing is moving beyond one local tissue and affecting systems that cannot tolerate much disruption. The lungs do not appreciate swelling. The circulation does not appreciate leaking vessels. The brain is unimpressed by falling blood pressure. The throat deserves special attention, because it is one of the places where a reaction can feel mild right up until it does not. A sense of fullness, a lump in the throat, repeated throat clearing, hoarseness, trouble swallowing, or noisy breathing are all concerning signs because they may point to swelling in the upper airway. Medical references stress that these symptoms should be taken seriously. A person may look less dramatic than expected and still be in real danger if the airway is beginning to narrow. This is one reason anaphylaxis can be deceptive. It is not always cinematic. It may begin with a person saying their throat feels strange, or that their voice sounds wrong, or that they suddenly feel dizzy and need to sit down. Biology rarely waits for better lighting before becoming urgent. Then there is the matter of shock, which sounds like a large dramatic word, but at heart means the circulation is failing to support the body properly. In anaphylaxis, widespread vasodilation and increased vascular permeability can cause blood pressure to drop. A person may become pale, cool, clammy, weak, confused, or faint. Their pulse may become rapid and weak as the heart tries to compensate. Severe, untreated anaphylaxis can be fatal, and public first aid guidance emphasises not waiting to see whether things simply improve on their own. That sense of urgency exists because once airway swelling or shock develops, time matters very much. The body's false alarm has become a true emergency, not because the allergen itself is inherently powerful, but because the body's response to it has become too broad and too intense. Something else that makes severe reactions difficult is that they do not always end when the first wave seems to settle. Allergy organisations and medical references describe the possibility of a second reaction, sometimes called a biphasic reaction, in which symptoms return hours later after an initial improvement. Not every severe reaction does this, and not every second wave is clinically significant, but the possibility is important enough that emergency evaluation and observation are often recommended after suspected anaphylaxis. That can feel frustrating, especially if the person begins to feel better and would much rather go home, preferably far away from whatever caused the entire fuss. But from a medical point of view, the body has already demonstrated that it is willing to overreact with commitment, and no one is eager to discover whether it has an encore planned. This is where treatment becomes very clear. For severe allergic reactions and anaphylaxis, epinephrine, also called adrenaline, is the first-line treatment. Major allergy and medical sources are unusually direct about this. Epinephrine should be given promptly in suspected anaphylaxis, because it works on the dangerous parts of the reaction that antihistamines do not control adequately or quickly enough. It helps support blood pressure, reduce swelling in the airways, and improve breathing. Antihistamines can help with some allergy symptoms, but they are not enough to treat anaphylaxis and work too slowly to be relied on in a severe reaction. That distinction matters. Histamine may be one of the early stars of the reaction, but by the time the whole system is in trouble, simply dimming itch and rash is not remotely the same thing as rescuing the airway and circulation. Public emergency guidance also stresses urgent medical help. Mayo Clinic advises calling emergency services right away for signs of anaphylaxis and using an epinephrine auto-injector if available. Its first aid guidance notes that severe untreated anaphylaxis can lead to death within half an hour, and recommends emergency evaluation even if symptoms start to improve, because recurrence can happen. That may sound stern, but it reflects the basic reality that anaphylaxis is not the same thing as an ordinary itchy rash. Once breathing, throat symptoms, circulation, or multiple systems are involved, the body is no longer just being overprotective in an inconvenient way. It has created a situation that can move faster than comfort allows. There is, however, something quietly reassuring in understanding the pattern. A serious allergic reaction does not become dangerous by magic. It follows recognizable biological rules. Mild symptoms become more concerning when they are joined by airway signs, faintness, weak rapid pulse, repeated vomiting, confusion, or swelling in critical places. More than one body system becoming involved is an important clue. So is speed. So is the person's history of severe allergy or asthma. The more we understand those patterns, the less mysterious the emergency becomes, even if it remains frightening. The body is still acting through mediators, vessels, muscles, nerves, and immune memory, The stakes are simply higher because the battlefield has widened, and perhaps that is the deepest difference between a mild reaction and a fierce one. In a mild reaction, the body is loudly mistaken in one place. In a severe one, the mistake spreads. The nose is no longer merely irritated. The throat may narrow, the skin is no longer only itchy, the circulation may falter, the gut is no longer just uneasy. The whole body may begin signalling distress. The immune system, having mistaken a harmless thing for a dangerous one, now responds with the kind of force it was meant to reserve for true emergencies. Once that happens, the question is no longer why this pollen, food, sting, or medication seemed offensive to the body. The question becomes why some bodies are so much more prone to making that mistake in the first place, and why one person can live casually beside a trigger that sends another into a crisis. By the time an allergy becomes obvious, it can feel as though the body has made a very personal decision. This flower, this cat, this food, this room, absolutely not. The reaction feels so specific that it is easy to imagine a single hidden cause, one switch thrown somewhere deep inside. But allergic bodies are usually made not by one factor, but by a long collaboration between inheritance, barrier tissues, immune training, microbes, early exposures, and the conditions of daily life. That is why two children in the same family can grow up under the same roof and still end up with different allergic stories. It is why one person can lie in a meadow without consequence, while another meets the same grass and begins sneezing like a machine with hurt feelings. The allergic response may look sudden, but the tendency behind it is usually built over time. The first piece of that story is genetics. Allergic disease tends to run in families, and major allergy organisations note that a family history of allergies is one of the strongest risk factors for developing allergic disease. That does not mean a parent passes down one exact allergy in a tidy package, as if peanut allergy or hay fever were inherited like eye colour. It means what is often inherited is a tendency toward atopy, the broader predisposition to make IgE antibodies and develop conditions such as eczema, allergic rhinitis, asthma, or food allergy. A child may inherit an immune system that is a little more suspicious, a barrier that is a little more fragile, or an inflammatory style that is more likely to lean toward type 2 allergic pathways. The family resemblance lies more in the readiness to become allergic than in one perfectly matching list of triggers. That inherited tendency is important, but it is not destiny. If it were, allergic disease would unfold with much more boring predictability than it actually does. Instead, genes create a landscape of risk. They shape how reactive the immune system may be, how sturdy the skin barrier may be, how tissues respond to irritation, and how likely the body is to produce certain kinds of inflammatory signals. Then environment, timing, and experience move through that landscape, turning some possibilities into real conditions while leaving others unrealized. This is why allergy often feels unfair but not entirely random. The body may arrive with a certain set of vulnerabilities, yet it still has to meet the world in particular ways for those vulnerabilities to become a lived problem. One of the clearest examples of that gene and environment partnership is the skin barrier. The skin is not simply wrapping. It is an active border that keeps water in, keeps irritants and microbes out, and helps educate the immune system about what deserves attention. NIH-supported research has shown that certain genetic variations can impair skin barrier function, increasing water loss and raising the likelihood of atopic dermatitis or eczema. That matters because eczema is not just an itchy skin condition. It often sits early in a broader allergic pattern. NIH also notes that preventing or limiting early atopic dermatitis may help interrupt the so-called atopic march, the progression seen in some children from eczema to food allergy, and later to respiratory allergy and asthma. When the barrier is weak, the immune system may meet harmless environmental proteins through damaged skin, in a context that favours alarm rather than tolerance. This barrier idea helps explain why eczema can matter so much in the making of an allergic body. a child with inflamed, leaky skin is not only uncomfortable, their immune system may be learning the wrong lessons. NIH has described how children with atopic dermatitis and food allergy can show higher water loss from skin, more Staphylococcus aureus on the skin surface, and signs of an immature skin barrier even in skin that looks normal. Researchers have long suspected that food allergens and other proteins may reach immune cells more easily through dysfunctional skin, contributing to sensitization. In simple terms, the body meets ordinary substances through the wrong door, in the wrong mood, and decides they are dangerous. Later, those substances return and find mast cells already armed against them. The gut tells a complementary story. It is one of the body's main training grounds for tolerance. Food enters there constantly, and under healthy conditions, the immune system learns that most of what comes through that route is ordinary life, not invasion. NIAID lists eczema, genes, microbiome changes, and environmental factors among the factors that can increase the risk of food allergy. The implication is important. Allergic risk is not just about the allergen itself. It is about whether the body learns calmness or suspicion when it first meets that substance. If the skin teaches alarm while the gut fails to teach tolerance strongly enough, the odds begin to shift in the wrong direction. This is one reason early life timing matters so much. The immune system in infancy is still learning what kind of world it lives in. It is deciding constantly and quietly what belongs on the list of tolerated exposures and what belongs on the list of serious concerns. That is part of why feeding practices have changed in modern allergy prevention. NIH and NIAID report that introducing peanut-containing foods in infancy, according to established guidelines, reduced peanut allergy risk by 81% at age 5 in the original LEAP trial, and by 71% into adolescence in later follow-up. That is a remarkable finding because it shows that one route to a less allergic body is not endless avoidance, but early, appropriate education. The immune system can be taught peace as well as panic. There is something deeply reassuring in that. It means the allergic body is not simply born fully decided. It is trained, it is shaped, it is influenced by how the immune system first meets food, microbes, irritants, and inflamed tissues. That does not remove the role of genetics, but it softens the fatalism. A child with family risk is not doomed to collect every allergy available, like an unfortunate hobby. Their immune system is still developing its rules, and those rules can be nudged toward tolerance under the right conditions. NIH's long-term peanut findings are one of the clearest examples of that principle in action. Microbes are part of that education as well. NISD identifies changes to the microbiome, the microscopic organisms that live in and on our bodies, as one of the risk factors for food allergy. This fits a broader view of immune development in which the body does not grow up alone. It is shaped by constant conversation with bacteria, fungi, and other microbes, especially in the gut and on the skin. These microbial communities influence barrier health, inflammation, and the balance between reactivity and tolerance. When the microbiome is altered, whether through early antibiotic exposure, diet, illness, or other environmental changes, the immune system may receive a different education than the one it evolved to expect. That does not mean there is one perfect microbiome that solves everything, but it does mean the allergic body may partly reflect a changed microbial childhood. This is where older ideas such as the hygiene hypothesis have to be handled with a little care. The modern picture is more nuanced than the simple claim that cleanliness causes allergy. The point is not that soap has betrayed humanity. It is that immune training depends on diverse early life exposures, and some modern environments may provide a narrower or different set of microbial signals than those under which human immune systems evolved. AAAI notes that research on early exposure to animals has been mixed, but more recent work suggests that early exposure to cats and dogs, and especially growing up on farms, may in some cases protect against allergies and asthma. In other words, the body may learn tolerance more effectively in some richer biological environments, though the pattern is complex and far from identical in every child. At the same time, not all environmental exposures are helpful. Some are plainly aggravating. AAAAI states that reducing contact with airborne triggers early in life may delay or prevent allergy or asthma symptoms in some children, and notes that evidence is clearest for dustmate control. The same source emphasises that tobacco smoke exposure before or after birth increases the chance of wheezing in infancy and is linked to the development of asthma and other chronic respiratory illness. NEH, L, B, I similarly lists cigarette smoke, viral infections, allergens, occupational dusts and chemicals, and poor air quality among factors that can contribute to asthma risk or make symptoms worse. So the allergic body is shaped not only by what it lacks, but also by what it is burdened with. Air pollution adds another layer to the story. WHO reported in 2025 that air pollution and climate change together worsen the health effects of allergens such as pollen and other airborne biological particles, contributing to more inflammatory and allergic conditions. The same WHO brief notes that rising carbon dioxide and higher temperatures are linked to earlier and longer pollen seasons and greater pollen production, while particulate matter can increase pollen allergenicity. That means some bodies are not only genetically prone and immunologically primed, but also living in environments where the allergens themselves are more abundant, seasons are longer, and barrier tissues are exposed to more irritation. The allergic body, then, is not merely made from within, it is also made by the air it keeps meeting. This environmental shaping helps explain why allergy seems so modern in its spread without being entirely new. The immune system's machinery is ancient, but the setting in which that machinery operates keeps changing. Urban living, indoor allergens, altered diets, microbial differences, pollution, climate effects on pollen, and patterns of early childhood exposure all influence how often the immune system is nudged toward one response style or another. Some people inherit a stronger tendency, some have more fragile barriers, some encounter more inflammatory triggers early, and some are simply exposed to a more allergy-promoting environment for years. The body is not reacting in a vacuum, it is reacting inside a century. There is also the question of why one allergic condition so often travels with another. AAAAI notes that allergic disease includes hay fever, eczema, hives, asthma, and food allergy, and that a family history raises risk broadly across these conditions. NIH has described eczema as an early step in the atopic march, where atopic dermatitis can progress to food allergies and sometimes to respiratory allergies and allergic asthma. This does not happen to everyone, but it reflects the fact that the same underlying tendencies, impaired barriers, type 2 inflammation, IgE readiness, reactive tissues, can express themselves in different organs over time. The allergic body is often not a single organ problem. It is a style of immunity that keeps finding new places to be overprotective. Even so, the exact final form remains personal. One child develops eczema and later outgrows most food sensitivities. Another has hay fever and never develops asthma. Another reaches adulthood with no obvious allergy and only then begins reacting to pollen or pets. AAAAI notes that stress, infection, and environmental changes can alter the immune system over time and increase the risk of developing allergies later in life. That means allergic tendency is not fixed only in infancy. It can be reshaped by infections, tissue injury, hormonal changes, occupational exposures, or repeated contact with irritants and allergens. The body is always learning, though it is not always learning wisely. This helps explain why siblings can differ so much. They may share parents and a home, but they do not share a perfectly identical immune history. One may have had more eczema early on. One may have had a different microbiome after illness or antibiotics. One may have met foods at a different moment of development. One may have spent more time with a pet, outdoors, or in daycare. One may simply have inherited a slightly different set of genetic tendencies. The allergic body is made from many small influences accumulating over time, and small differences early can widen into very different outcomes later. It is not that one child was lucky and the other was not, though from the family sofa it may certainly feel that way. It is that immune biographies diverge even inside the same household. There is also an emotional challenge here. Because allergic diseases often run in families, parents can feel they have somehow handed down a flaw or made one wrong environmental decision that caused the entire problem. The biology is not so simple, and that is worth saying plainly. Allergies emerge from gene-environment interaction, not from one guilty moment involving a dusty blanket, a cat, or a spoonful of peanut butter introduced on the wrong Tuesday. Modern allergy science keeps moving away from blame and towards systems. Barriers matter, microbes matter, exposures matter, timing matters, but there is rarely one villain. The body becomes allergic through layers of influence, not one dramatic betrayal. And yet, despite all that complexity, a simple pattern still shows through. The people most likely to react are often those whose bodies combine inherited sensitivity with vulnerable barriers and an immune education that leaned too often toward alarm. A family history raises the baseline risk. Eczema may open the door, microbiome changes may alter tolerance, pollution and smoke may irritate tissues and amplify responses. Delayed or mistimed exposure to some foods may reduce the chance to build oral tolerance. Climate and air quality may increase allergen burden. None of these guarantees allergy by itself, but together they help explain why some bodies remain calm, while others become exquisitely reactive to the ordinary world. In that sense, the allergic body is not weak. It is vigilant in a way that has lost its proportion. It has inherited or acquired a style of defense that is too quick to classify harmless things as threats, too ready to coat mast cells in IgE, too inclined to meet pollen, food proteins, or animal dander with the chemistry once meant for more serious intruders. That is why the symptoms can feel so exaggerated. The system has not failed to defend. It has defended too hard and too early against the wrong things. The real work of treatment, then, is not merely to suppress a runny nose or flatten a hive, but to calm that overcommitted defense system in practical ways, whether by blocking histamine, reducing inflammation, retraining immune tolerance, or preventing exposure when prevention is the safest path. Once you understand how histamine is released and how allergic symptoms take shape, the next natural question is how anyone calms all of it down. The answer, rather sensibly, is that treatment can happen at several different levels. Some treatments try to block the effects of histamine after it has already been released. Some reduce the broader inflammation that keeps tissues swollen and reactive. Some aim to prevent the body from meeting the trigger in the first place. Some, more ambitiously, try to retrain the immune system so it becomes less alarmed over time. And in the most serious reactions, treatment is not really about soothing at all. It is about rapidly rescuing breathing and circulation before the body's false alarm does real harm. Allergy treatment, then, is less like one magic switch and more like a set of tools, each aimed at a different part of the storm. The simplest level of treatment is avoidance, which sounds dull until you remember how often it works. If a person knows that a certain cat, a certain pollen season, a certain food, or a certain room full of dust reliably starts the whole process, reducing exposure can matter enormously. AAAAI notes that for eye allergies, practical steps such as keeping pets out of the bedroom, using a vacuum with a HEPA filter, wearing sunglasses outdoors, or rinsing the eyes with saline after outdoor exposure can reduce symptoms. NHLBI says avoiding the allergens that trigger allergic asthma can help control symptoms and prevent flare-ups. This is not glamorous medicine, but then neither is spending the evening negotiating with your own sinuses. Sometimes the quietest treatment is simply giving the immune system less to be suspicious of. Still, avoidance is rarely perfect, especially for things like pollen, dust mites, molds, or the general fact that food labels can be treacherous in their own small bureaucratic way. That is where antihistamines enter the story. Antihistamines do not stop mast cells from having released histamine already. Instead, they block cells from receiving some of histamine's message, especially through H1 pathways, which is why they can reduce itching, sneezing, runny nose, watery eyes, hives, and some swelling. Mayo Clinic describes oral antihistamines as easing many allergy symptoms, including runny nose, itchy or watery eyes, hives, and swelling, while antihistamine nasal sprays can help with sneezing, itchy or runny nose, congestion, and postnasal drip. In other words, antihistamines do not silence the alarm room where the panic began, but they do stop some of the louder speakers around the building. There is, however, a small catch, and it is one many people know personally from trying to be both less itchy and more awake at the same time. Some antihistamines cause drowsiness. Mayo Clinic notes that older or more sedating antihistamines, such as diphenhydramine, chlorpheniramine, hydroxyzine, and brompheniramine, are more likely to make people sleepy, while medications such as fexofenadine, loratadine, levocetirizine, desloratadine, and often cetirizine are less likely to do so, though cetirizine and loratadine can still cause drowsiness in some people. This is one of those moments where the biology is oddly revealing. Histamine helps with wakefulness in the brain, so blocking it there can make the world feel softer, slower, and less urgent, which is lovely for bedtime but less ideal if one is meant to be driving, working, or pretending to follow a meeting. For hay fever and other nasal allergies, treatment often works better when it goes directly to the battlefield. Corticosteroid nasal sprays, according to Mayo Clinic, are very effective on their own for ongoing or seasonal hay fever, and AAAA's 2024 research summary reported that intranasal treatments were often more effective than oral medications for improving seasonal allergic rhinitis symptoms, especially when intranasal corticosteroids were compared with oral antihistamines or oral leukotriene receptor antagonists. That makes good sense. If the problem lives in the swollen, reactive lining of the nose, sending the medicine directly there is usually more useful than hoping a tablet drifting through the bloodstream will sort it out by general persuasion alone. The nose in these situations tends to appreciate a direct conversation. Nasal sprays also come in several forms, which is useful because allergic misery likes variety and so must treatment. AAAAI's drug guide lists intranasal antihistamines, nasal steroids, combination antihistamine steroid sprays, cromolyn as a mast cell inhibitor, ipratropium for runny nose, and short-term decongestant sprays for reducing nasal swelling. That variety reflects the fact that nasal symptoms are not all the same. Sometimes the main problem is itching and sneezing. Sometimes it is drip. Sometimes it is deep congestion. Sometimes it is the full symphony. Different medicines interrupt different parts of that pattern. The body may be conducting a false alarm with great enthusiasm, but modern medicine, to its credit, has developed a respectable number of ways to interrupt the performance without having to cancel the whole concert hall. Eye symptoms have their own little corner of treatment because the eyes are exposed, delicate, and very committed to complaining when irritated. AAAAI notes that antihistamine eye drops, mast cell stabilizer drops, and combination drops are used for allergic conjunctivitis, while saline rinsing after outdoor exposure can help wash allergens from the ocular surface. SSAAAI also says corticosteroid eye drops can be effective when other treatments do not work, but they should be managed carefully because of risks such as glaucoma, cataracts, and infection. This is a useful reminder that treatments differ not only in strength, but in how much supervision they require. The eyes are not especially forgiving of improvisation. They prefer careful chemistry and good manners. When the skin is involved, treatment again follows the tissue. Mayo Clinic describes corticosteroid creams as helpful for allergic skin reactions such as itching, scaling, or changes in skin colour, while also noting that long-term use, especially of stronger preparations, can thin the skin and cause other effects. For rapidly itchy rashes or hives, antihistamines may help reduce symptoms, but for chronic inflammatory skin disease like eczema, the treatment strategy often has to include barrier repair and more sustained anti-inflammatory control, not just histamine blockade. This matters because the skin does not merely itch, it also dries, cracks, inflames, and allows the outside world in too easily when its barrier is compromised. A truly useful treatment for allergic skin disease often has to calm the immune system and help the wall itself recover. The lungs, as ever, demand a little more respect. NHLBI says typical treatment for allergic asthma includes inhaled corticosteroids, and its guidance notes that inhaled corticosteroid treatment is the preferred controller therapy for persistent asthma because it helps control airway inflammation over time. In practical terms, this means the medicine goes where the swelling and reactivity are, directly into the breathing tubes themselves. Some inhalers also combine corticosteroids with bronchodilators, which help keep the airway muscles more relaxed. This is important because allergic asthma is not just a matter of feeling sniffly lower down in the body. It is a condition in which inflamed airways can tighten, narrow, and fill with mucus, and that requires long-term control, not merely hoping the chest will stop being offended on its own. Some medicines aim at mediators beyond histamine. Mayo Clinic notes that leukotriene inhibitors block leukotrienes, chemicals that contribute to allergy symptoms, and that montelukast is one such prescription medicine used for hay fever and asthma. These drugs are not usually the first answer for every person with allergies, but they exist because histamine is only part of the allergic cascade. Once mast cells are activated, the body produces a broader inflammatory language. Blocking one word in that language may help a great deal, but sometimes a second word matters too. The allergic body, after all, is seldom satisfied with a single pathway when it can employ several at once and insist they all contribute meaningfully to the experience. Then there are oral corticosteroids, which are more like bringing in a stronger, broader force when a reaction has become severe enough to justify it. Mayo Clinic says oral corticosteroids are used to treat severe symptoms caused by allergic reactions, but also notes important long-term risks, including high blood pressure, cataracts, osteoporosis, ulcers, high blood sugar, muscle weakness, and growth effects in children. That balance matters. These medicines can be powerful anti-inflammatory tools, but they are not the sort of thing one wants to use casually or for long stretches if better targeted options exist. They are more like the body's version of sending in very stern adults to restore order to a room that has become impossible. Effective, yes, but not the first preference for everyday management. When the reaction is severe enough to involve anaphylaxis, however, the conversation changes entirely. This is the point where antihistamines are no longer the heroes of the hour. Mayo Clinic states plainly that epinephrine shots are used to treat sudden, life-threatening allergic reactions, and AAAI/ACAAI's 2023 anaphylaxis practice parameter and older immunotherapy parameter both emphasize that epinephrine is the treatment of choice in anaphylaxis, while antihistamines and corticosteroids are secondary and should not replace it. FDA likewise states that prompt administration of epinephrine is part of current treatment when accidental food exposure leads to anaphylaxis. This is worth saying without softness. When airway swelling, breathing trouble, throat symptoms, or dangerous circulatory changes are developing, the right treatment is not something for allergies. It is emergency treatment. Histamine may have helped start the crisis, but by then the body needs rescue, not gentle persuasion. That is why people at risk of severe reactions are often told to carry epinephrine auto-injectors and to seek emergency care even after using one. Mayo Clinic advises that some severe reactions may require a second injection and that emergency medical care is still needed. This reflects the reality that anaphylaxis can progress quickly, involve more than histamine alone, and in some cases recur after initial improvement. There is something sobering in that, but also clarifying. Mild allergy treatment is often about comfort and control. Severe allergy treatment is about buying the body time, preserving the airway, supporting blood pressure, and getting skilled help involved before the chemistry outruns the person experiencing it. Beyond symptom control lies a more ambitious idea. What if the immune system itself could be trained to stop overreacting? That is the basic promise of allergen immunotherapy. AAAAI explains that allergy shots work by exposing the body to increasing amounts of a particular allergen over time, so that it develops resistance and tolerance. The same organisation says allergy shots can decrease symptoms of allergic rhinitis, conjunctivitis, allergic asthma, and stinging insect allergy, and may prevent new allergies from developing and, in children, reduce progression from allergic rhinitis to asthma. This is one of the more hopeful parts of allergy medicine because it aims not just to mop up mediators after the alarm sounds, but to teach the immune system a different opinion about the trigger itself. Immunotherapy also demands patience, which perhaps is only fair given how long the immune system took to learn the wrong lesson in the first place. AAAAI says the build-up phase of allergy shots often lasts 3 to 6 months, with maintenance injections then spaced every 2 to 4 weeks, and total treatment commonly continuing for 3 to 5 years. Some people gain lasting remission of symptoms, while others may relapse after stopping. That is a very human sort of medical arrangement. Not dramatic, not instant, no thunderclap cure, just repeated careful teaching until the body becomes less suspicious. It is almost like convincing a nervous guard dog, over many months, that the postman has been here before and truly does not require a full tactical response. Not all immunotherapy comes by shot. AAAI's current drug guide lists FDA, approved sublingual immunotherapy tablets for dust mite, timothy grass, mixed grass pollen, and ragweed allergy, taken under the tongue, generally once daily, with the first dose given in a doctor's office. AAAI also notes that these tablets offer an additional option for allergic rhinitis or rhinoconjunctivitis triggered by those specific allergens. This is an elegant example of modern medicine adapting to the same principle in a different form. The immune system is still being taught through controlled exposure. It is just being taught through the mouth rather than the arm. Biology, as always, is happy to use more than one classroom. Food allergy is a more difficult field, partly because the stakes are higher and the line between management and danger is thinner. FDA states that there is currently no cure for food allergy, and that strict avoidance of the relevant food remains part of treatment, along with prompt epinephrine for anaphylaxis if accidental exposure happens. At the same time, newer options have appeared. FDA says Palforzia is an oral immunotherapy product for confirmed peanut allergy, approved for initial dose escalation in patients aged 1 through 17 years, with updosing and maintenance continued in patients 1 year and older, and that it must be used with a peanut-avoidant diet. AAAAI also notes that oral immunotherapy can desensitize many patients to foods like peanut, egg, and milk, though the benefit often depends on ongoing exposure and is not the same as a guaranteed permanent cure. Another newer example of immune control is omalizumab, better known by the brand name Xolair. In February 2024, FDA approved Xolair for certain adults and children 1 year and older with IgE-mediated food allergy to reduce allergic reactions, including reducing the risk of anaphylaxis after accidental exposure to one or more foods. FDA also makes clear that people taking Xolair must still avoid the foods they are allergic to, and that the drug is not approved for immediate emergency treatment of allergic reactions. That distinction matters. Omalizumab does not grant carefree eating or replace emergency preparedness. What it does is bind IgE, helping reduce the ability of that antibody to trigger allergic reactions, which is a much more strategic sort of medicine than simply trying to chase histamine after the fact. Biologic medicines more broadly are becoming part of how doctors treat allergic disease when ordinary measures are not enough. AAAAI's drug guide describes immunomodulator or biologic medications as drugs that directly change immune system behavior. and NHLBI notes that biologic medicines may be added in some patients with allergic asthma. This is a significant shift in the philosophy of treatment. Rather than only blocking symptoms at the surface, biologics can target specific immune pathways that drive the underlying disease. That does not make them simple, inexpensive, or appropriate for everyone, but it does show how much allergy medicine has changed. We are no longer limited to handing tissues to the nose and hoping for the best. We are learning how to interrupt the conversation that made the nose so upset in the first place. Even with all these options, one quiet truth remains. Most allergy treatment is not about erasing the immune system. It is about restoring proportion. Antihistamines reduce the force of histamine's message. Nasal sprays and inhaled steroids reduce local inflammation. Eye drops calm irritated surfaces. Avoidance limits the trigger. Epinephrine rescues the body when the reaction has become dangerous. Immunotherapy and biologics try to retrain or redirect the response itself. Each approach is a way of telling the body, gently or urgently depending on the situation, that it does not need to behave as though every grain of pollen, every dust mite particle, every brush with animal dander, or every trace of food were a mortal threat. And perhaps that is what makes this whole subject so interesting. The body is not evil, foolish, or broken in some dramatic theatrical sense. It is protective. It is vigilant. It is trying to keep borders safe. Treatment works best when it respects that truth while correcting the excess. When it softens the histamine, calms the swelling, steadies the airways, and, if possible, slowly teaches the immune system that not everything unfamiliar is an enemy. And that brings us very close to the deepest question underneath the whole story, because once we have seen how the body overreacts and how medicine tries to calm it, what remains is the gentler thought that this whole cascade began as an act of protection, only one that lost its sense of proportion along the way. There is something strangely moving about the whole story of allergy once you have followed it all the way through. At the beginning, it can seem like a story about inconvenience, a blocked nose in spring, an itchy rash after contact with something ordinary, watery eyes, a few sneezes, maybe a reaction to a food that most people around you can eat without a second thought. Then, as you look more closely, the picture changes. It becomes a story about cells waiting quietly in the skin, nose, lungs, and gut. It becomes a story about chemical signals stored in tiny granules, about antibodies that remember what the body has decided to fear, about tissues that swell, leak, tighten, and protest because the immune system believes it is doing something important. And by the end of it, the whole thing feels less like random betrayal and more like a misunderstanding inside a system that was built to protect life, even if that protection sometimes arrives in the wrong place, at the wrong time, and with far too much conviction. That may be the gentlest and most important thought to carry away. The allergic body is not trying to punish you. It is not attacking for sport. It is not waking up in the morning, reviewing the day's plans, and deciding that this would be an excellent time to ruin a picnic or make a sandwich emotionally complicated. It is protecting, or rather, it is attempting to protect. The trouble is that protection is not the same as wisdom. The immune system is fast, practical, and deeply shaped by survival. It does not spend much time in calm reflection. It notices patterns, remembers exposures, positions cells at the borders, and reacts when it believes the borders have been threatened. If it mislabels something harmless as dangerous, the response can still be very real. The error lies not in the existence of the defense, but in the target chosen for it. That is a very human kind of problem, even though it happens in molecules and cells. A useful system can become unhelpful when it loses proportion. A good instinct can become troublesome when it begins seeing threats everywhere. The immune system, in allergies, has done something like that. It has taken a set of legitimate tools, histamine, inflammation, swelling, mucus, muscle tightening, memory, rapid response, and used them against things that do not deserve such an answer. Grass pollen is not a parasite. Cat dander is not a venom. A peanut is not a hostile invader, and yet the body, in some people, responds with the seriousness it might have reserved for something much more dangerous. That seriousness is the key. Allergic reactions feel dramatic because the body means them. The response is misplaced, but it is not casual. Once you see that, symptoms begin to feel different in the mind. Not less uncomfortable, certainly. A blocked nose remains a blocked nose. Itching remains one of the least dignified sensations a person can endure in public. Hives are still alarming. Wheezing is still frightening. None of that becomes pleasant simply because you understand the mechanism, but understanding does soften the feeling of personal betrayal. The body is not behaving like an enemy. It is behaving like an overprotective guardian who has mistaken the neighbour for a burglar and is now making the situation much louder than anyone needed it to be. That does not make the disturbance less real, but it makes it easier to see the intention hidden inside it. And intention matters, even in biology. The cells involved in allergic reactions are not evil. Mast cells are not villains with tiny malicious plans. Basophils are not floating around the bloodstream looking for ways to make meals inconvenient. Histamine itself is not some dark substance reserved only for human misery. All of these things exist because they are useful. Histamine helps regulate the stomach. It helps shape immune defense. It plays a role in wakefulness. Mast cells help guard the borders. Basophils contribute to the body's broader language of protection. The machinery of allergy was not built for allergies alone. It was built because life at the boundary between self and world is risky. Skin can be broken. Airways can be invaded. Food can carry threats. Parasites, venoms, injuries, microbes, all have been part of the long history that shaped immune defense. The system is ancient because danger is ancient. Its mistake is not that it exists, but that it has become too suspicious of harmless things. That suspicion is part of what makes allergic disease so sad and so interesting at the same time. The body is doing something meaningful in a meaningless context. It sees danger in ordinary life. It interprets spring air as an event. It treats dinner like a problem to solve. It receives a pet into the room and behaves as though the walls have been breached. There is a kind of a lonely comedy in that, but also a deeper truth. The body does not experience the world in the same categories the conscious mind does. You may know perfectly well that the cat is friendly, that the pollen has no ambitions, that the strawberry is not plotting anything. The immune system is not interested in that level of reassurance. It works through exposure, memory, signalling, threshold, and training. It learns what to fear in its own language, and once it has learned the wrong lesson, it can be very stubborn about changing its mind. This is where medicine becomes such a humane project. So much of treatment is really an attempt to restore proportion. An antihistamine does not condemn the body. It quiets one of the louder signals. A nasal spray reduces local inflammation where the tissue has become too reactive. An inhaler helps the airways relax and breathe more easily. Barrier repair helps skin remember how to do its quiet job without asking the immune system to interfere so much. Immunotherapy, in its slow and patient way, tries to teach the body a new lesson about something it has wrongly feared. Even emergency treatment at its most urgent is an act of restoring balance. Epinephrine does not argue with the immune system philosophically. It simply steps in when the reaction has become too much and says firmly enough. In that sense, treatment is less a war against the body than a conversation with it. Calm down, stand down. This is not the threat you think it is. There is comfort in that idea because it invites a kinder relationship with the body, even when the body is difficult. It is easy to become frustrated with symptoms, easy to feel embarrassed by them, angry with them, tired of planning around them, easy to think of the body as unreliable or absurd when it reacts to small things with large consequences, and some days it truly is exhausting. Living with allergies, especially severe ones, means carrying awareness where other people get to carry ease. It means checking ingredients, reading the season in the air, thinking about dust and pets and medications and rooms and restaurants, and the possibility that something ordinary may not be ordinary for you. That burden is real. It should not be minimized. But it can exist alongside the gentler recognition that the body is still, underneath all of it, trying to keep itself alive. Bodies do this in many awkward ways. Fever can make a person miserable while helping slow infection. Pain can disrupt life while warning of damage. Fatigue can frustrate the mind while forcing rest. Nausea can seem cruel while trying to prevent further harm. The body is full of systems that do not prioritize comfort above all else. Allergy belongs to that family of imperfect protections. It is protection that has lost accuracy, but it is still protection in style. It still widens vessels, summons cells, stimulates nerves, produces mucus, contracts muscle, and changes tissue, because somewhere in its old biological memory, these are the moves that matter when something dangerous appears. It is doing the wrong dance to the wrong music, but it knows the dance for a reason. Perhaps that is why understanding allergy often creates not only knowledge, but a certain tenderness. When you step back from the details, from the receptors and antibodies and mast cells and sprays and tablets, what you are left with is a body trying very hard. Too hard, certainly, sometimes disastrously hard, but still trying. It is standing at its borders day and night, deciding what belongs and what does not, letting food in, letting air in, letting touch happen, maintaining skin, eyes, lungs and gut in a world full of particles, proteins and possibilities. That is a difficult job. Most of the time the body does it without being thanked. Most of the time tolerance works, breathing works, eating works, touching the world works, and no one notices the countless peaceful decisions being made on their behalf. It is only when the body gets it wrong that we suddenly become aware of the labour that has been going on quietly all along. That awareness can change the way one thinks about health. Health is not the absence of activity. It is the presence of well-regulated activity. A calm immune system is not asleep. It is wisely restrained. A healthy barrier is not passive. It is selectively open and selectively closed. A body without symptoms is not doing nothing. It is coordinating billions of decisions so smoothly that consciousness gets to ignore them. Allergy interrupts that invisibility. It takes processes that are usually hidden and makes them obvious. Suddenly there is swelling where there should be ease, mucus where there should be clear breathing, itching where there should be quiet skin, fear where there should be trust. But even in that disruption, the body is revealing what it has always been, a vigilant, complicated, deeply committed guardian of its own boundaries. There is another comfort here too. The body can learn. It can learn the wrong lesson, as allergies show, but it can also learn better ones. Children sometimes outgrow allergies. Immune systems can be retrained. Barrier tissues can recover. Better control is possible. Sensitivity can sometimes lessen. This does not happen for everyone, and not every allergy story bends toward ease, but the possibility itself is meaningful. The immune system is not a locked room. It is a changing system shaped by experience, treatment, environment, and time. That means the allergic body is not fixed only as a body that overreacts. It is also a body that can, under the right conditions, become less alarmed, less burdened, less quick to mistake the harmless for the dangerous. Biology can be stubborn, but it is rarely completely static. Even when the allergy remains, understanding it changes the relationship to it. A symptom becomes a message rather than a mystery. A trigger becomes something to manage rather than something to fear without language. Medicine becomes partnership rather than guesswork. There is something calming in naming the parts. Histamine, mast cells. IgE, barrier tissues. Inflammation, tolerance. These words do not cure anything by themselves, but they turn fog into structure. They let the mind hold what the body is doing with a little more steadiness, and steadiness matters. There is a difference between suffering inside confusion and suffering inside understanding. The body may still itch or swell or wheeze, but the mind no longer has to stand helplessly outside the process, wondering why it is happening. And perhaps, at the very end of this quiet journey, that is the thought worth resting with. The body is not perfect, and it was never meant to be. It was meant to survive. It was meant to notice. It was meant to protect its edges, repair its surfaces, remember danger, and react quickly when reaction might save life. In allergies, that ancient loyalty becomes clumsy. It mistakes harmless things for harmful ones and throws its weight behind the mistake. But the loyalty remains. The body is still on your side, even when its methods are poor. It is still trying to guard the gates, even when it has chosen the wrong guest to distrust. There is something almost reassuring in that, because it means the trouble comes not from indifference, but from care without enough nuance. So if the body has ever seemed unreasonable, tonight it may help to think of it a little differently. Not as a machine that failed, not as a traitor, not as a dramatic nuisance for no reason, but as a watchful creature shaped by old dangers and fast decisions, doing its imperfect best to keep a living boundary intact. Sometimes it gets the answer wrong. Sometimes it raises the alarm over pollen, fur, food, or dust. Sometimes it turns an ordinary afternoon into a lesson in immunology, whether anyone asks for one or not. But beneath the itching, swelling, sneezing, and fear, there is still a system trying to keep you here. Clumsy perhaps, overprotective certainly, misguided at times, but still protective. And that is not the worst thing to remember as the day settles down. Deep in the tissues, beyond thought, beyond language, your body keeps watch. It guards the borders. It repairs what it can. It learns, forgets, overlearns, and tries again. It may not always understand the world correctly, but it meets that world with effort and commitment every moment you're alive. Even its mistakes come from vigilance. Even its excesses come from a wish, however badly expressed, to preserve you. There is a quiet dignity in that. Not perfection, not elegance, but devotion. The kind written not in intentions or promises, but in cells, signals, and the constant work of staying alive long enough to rest. And with that thought, the whole story softens a little. Histamine becomes less like a villain and more like a messenger used too forcefully. Allergy becomes less like betrayal and more like protection that has lost its measure. The body becomes less like an adversary and more like an anxious guardian who loves too strongly for its own good. And somewhere inside that realization, there is a small kind of peace, enough perhaps to let the mind loosen, the breathing slow, and the night take over from here.